Welcome to Sleepy Science Facts. It's so lovely to have you here. As you settle in, taking a moment to unwind, I invite you to find a cozy position, perhaps nestled under a soft blanket or resting on a comfortable pillow. Allow your mind to drift softly, and if you enjoy these gentle explorations, a quiet little reminder to like and subscribe will help us continue sharing these peaceful thoughts together. To think about clouds is to consider the subtle beauty of how they exist in our world. Far above, where the air is tranquil and cool, clouds are in a constant dance of formation and transformation. Their presence and shape are deeply connected to tiny particles that float unseen in the atmosphere. These small specks, known as cloud condensation nuclei, can be bits of dust, grains of salt, or even minute pollutants. They are crucial for the process that allows clouds to take form. When the air cools down, moisture in the atmosphere becomes ready to condense. Yet, this moisture would remain as invisible vapor without those tiny nuclei. These particles serve as gathering places, offering a surface where water vapor can cling and slowly cluster together. With time, the vapor condenses into small droplets, or in colder conditions, into ice crystals. This seemingly simple act is what gives rise to the clouds we see drifting across the sky. As more droplets accumulate, clouds grow and can begin to spread across vast areas, painting the skies in shades of white, gray, or even darker hues before a storm. Each change in temperature or humidity can alter their appearance, leading to different types of clouds, each serving unique roles in our atmosphere. As this process continues, clouds bring their gentle influence to our weather, shaping our daily experiences in subtle yet significant ways. The realm of clouds is rich with nuances as they shift and dissipate, ever-changing and ephemeral. In moments where you pause to look up, remember that what you are seeing is the outcome of a delicate balance of unseen elements working together in harmony. This connection between tiny particles and vast expanses of moisture embodies a serene rhythm of nature, crafting the very air we breathe and the weather we experience. There is always more to explore beneath the surface of such wonders, and we can gently draw upon these rich layers of understanding in the cozy stillness of this evening. In the silent expanse of the sky, high-altitude clouds harbor secrets that touch the fabric of our planet. These clouds, often composed of tiny ice crystals, exist in delicate balance, caught between the coolness of their atmosphere and the warmth that may melt them away. Over long stretches of time, these clouds play a quiet yet significant role in the story of Earth's water distribution. As ice crystals within these clouds gather slowly over time, they begin to accumulate, contributing to the larger systems of glaciation. This buildup can affect regions across vast distances, influencing how water moves in cycles that are both rhythmic and profound. When conditions align just right, melting occurs, releasing water that has been stored aloft for many seasons. This gradual transformation from solid to liquid has an understated impact on sea levels, shifting them over eons in gentle waves that remind us of nature's larger cycles. Glaciation and deglaciation are not merely concepts confined to textbooks. They are processes that pulse through Earth's history, sculpting landscapes and shaping ecosystems as they unfold. Each cycle allows for redistribution of water, subtly altering where it rests upon the surface and how it moves across our planet. It is a quiet story, one bestowed by clouds that float so high above us, changing and reshaping the world in ways we often cannot see. This dance of ice and water carries on, a continuing interplay that connects all existence, threading together the fabric of life. There is a tranquility in knowing even in the stillness of the night, these processes are ongoing, weaving the intricate patterns of climate and environment. Just as clouds gather and disperse, so too does this ancient cycle continue, softly influencing everything we know. Over many seasons, rocks endure the gentle touch of time and elements, breaking down slowly through a process known as weathering. This gradual transformation unfolds quietly, revealing the minerals hidden within their depths. Each minute fracture and crack allows particles to emerge, cascading into the soil and surrounding water, enriching the very foundation of life on Earth. As minerals seep into the ground, they become part of a slow dance, nourishing the soil that cradles roots. This infusion of essential elements nurtures grasses, trees, and plants, creating a tapestry of life that thrives in harmony with its environment. Over countless years, these interactions sculpt ecosystems, fostering connections between organisms that depend on one another for growth and survival. The minerals released from rocks carry a range of nutrients, each with its unique purpose. Some support the formation of vibrant green leaves, while others play a role in strengthening the structure of stems or enhancing the flavor of fruits and vegetables. This interplay ensures that the energy of the sun, filtered through the leaves, can be converted into sustenance for both plants and the creatures that inhabit these ecosystems. In these quiet moments of connection, life flourishes, a testament to the unseen gifts offered by the slow and persistent work of weathering. As rocks yield their essence, they contribute to a continuous cycle of nourishment and rebirth, shaping the landscape in ways that take time to fully appreciate. The steady release of minerals echoes through generations, resonating softly with the unfolding stories of life below and above the surface. A serene reminder persists that even the slowest of transformations can hold great significance in the eternal rhythm of the natural world. In the expansive sky, clouds drift and take shape, their formation a delicate balance, influenced by moisture in the air. When the air holds ample moisture, tiny droplets of water begin to gather around microscopic particles known as condensation nuclei. These nuclei serve as the building blocks for clouds, allowing the water vapor to coalesce gently. As air cools, especially when it rises to higher altitudes, water vapor condenses around these nuclei, creating clusters of water droplets that float softly. Yet this process is inherently sensitive. If the air becomes overly dry, the potential for cloud formation diminishes significantly. Even with the presence of condensation nuclei, the lack of moisture prevents these droplets from growing robust and instead invites evaporation. They simply vanish into the atmosphere, leaving the sky clear and untouched. The interplay between temperature and humidity is crucial in this serene dance. Warmer air can hold more moisture, and the cooling of this air can lead to the peaceful creation of clouds, bringing a soft veil to the sky. In contrast, when the atmosphere lacks sufficient moisture, the chance for clouds to linger is fleeting. They may appear briefly, only to dissolve back into invisible vapor. As humidity ebbs and flows, the formation of clouds becomes a gentle reminder of nature's rhythms. It underscores the intricate balance of elements required to witness clouds drifting gracefully, painting the sky with shades of white and gray. When the conditions are just right, clouds embody the calm and beauty of the ever-changing atmosphere, floating softly and serenely as they journey through the skies. Time flows onward, inviting contemplation of these transient formations and the quiet processes that give them life. Clouds, with their soft, billowing forms, have a limit to how high they can rise. In the warm tropical regions, clouds can ascend up to about 18 kilometers, which is approximately 60,000 feet. This height marks marks the tropopause, a boundary between the troposphere, where weather occurs, and the stratosphere above. In this region, the atmosphere is rich with warmth and moisture, providing ideal conditions for clouds to flourish. As clouds reach this lofty boundary, the air begins to change. It transitions into a cooler and thinner layer, where the dynamics of cloud formation become more complex. The temperatures drop significantly here, making it increasingly difficult for the water droplets to linger. At these higher altitudes, the air can hold less moisture, which creates a natural limit to the size and height of clouds. Above the tropopause, the conditions are no longer conducive to the usual processes that allow clouds to develop. The atmosphere becomes too sparse for the water vapor to condense effectively. Instead of gathering into droplets, the moisture finds it hard to maintain its form against the cold and thin air, resulting in a gentle dissipation into the surrounding atmosphere. The beauty of this height limit allows for a unique interplay of weather patterns below, where clouds can form and transform with grace and fluidity. Observing the clouds, one might notice how they float elegantly within their boundaries, painting the sky with their ever-changing shapes. This tranquil presence speaks of the vast, harmonious balance in the atmosphere, reminding us of the serene processes that govern the sky's canvas. Each cloud, rising to its maximum height, holds a story of its formation, shaped by the interplay of warmth and cooling, existing peacefully in the expanse above us. The Pacific Decadal Oscillation, known as the PDO, is a complex and enduring climate pattern that unfolds quietly across the North Pacific Ocean. This oscillation moves in cycles, where a phase of warmer surface temperatures is followed by a phase of cooler temperatures. These cycles can stretch across 2 to 3 decades, creating a long-term rhythm in the ocean's behavior. As the surface temperatures change, they interact with the vast atmosphere above. The warmth or coolness of the ocean influences the air currents, shifting atmospheric circulation patterns in subtle but impactful ways. When the sea surface is warmer, it can lead to changes in how clouds form and how precipitation patterns develop in surrounding regions. The PDO acts as a guiding force, determining where clouds might gather or dissipate, inducing either more cloudiness or clear skies depending on the phase it is in. These changes do not happen abruptly. Instead, they unfold slowly over many years, allowing ecosystems and weather systems to adapt or respond. As the ocean's surface holds warmth or coolness, the air above it also transforms, creating a deeply interlinked system of ocean and sky. The gradual shift can alter regional climates, influencing everything from rainfall to seasonal weather behavior. The movement of air and sea in this delicate dance exemplifies the intricate balance of natural systems. It is a reminder of the long-term cycles that shape our environment, flowing gently like the tides, with each phase fostering its own unique conditions. As the PDO continues its slow oscillation, the vast expanse of the North Pacific remains a canvas of changing patterns, where water and air weave together in a persistent, harmonious interplay, nurturing the world around it. Glaciers, those immense rivers of ice, move with a quiet, persistent force. Over centuries, they traverse vast stretches of land, their slow movement creating a profound impact on the earth beneath. As they flow, they carry with them not just ice, but also rock and sediment, shaped from the landscape as they advance. This gentle yet powerful action contributes to a gradual but steady reshaping of the terrain. The slow march of glaciers carves deep valleys, creating U-shaped hollows that stand as testaments to their enduring presence. As they grind against the Earth's surface, the ice erodes rock and soil, leaving behind unique and They can create fjords, where towering cliffs meet serene waters, and valleys that resonate with the echoes of their icy passage. In their movement, glaciers respond to the delicate balance of temperature and pressure, inching forward in a perpetual cycle of accumulation and melting. Each season brings slight variations as snowfall contributes to their mass, while warmer temperatures cause some of their edges to retreat. Yet even during these retreats, the influence of glaciers remains etched in the landscape long after the ice has receded. Across the continents, the silent work of glaciers continues, subtly shaping the earth over time. They remind us of the slow, transformative power of natural forces, moving at a pace that encourages a deep sense of tranquility. As they flow, they encapsulate a world of change that unfolds in a serene rhythm, maintaining their presence in the fabric of the land. Within the vast expanse of clouds, even those that appear uniform harbor a dance of small, swirling movements. These subtle eddies and currents exist beneath the surface, powered by kinetic energy that courses throughout the cloud. This energy creates a gentle turbulence, allowing different layers and areas of the cloud to interact with one another. These internal circulations, though sometimes barely perceptible, play a crucial role in the development of clouds. They work to mix the various water droplets suspended within, creating a delicate balance of condensation and evaporation. As these movements occur, they contribute to the overall texture and structure of the cloud, influencing its formation over time. In these gentle whirlpools, tiny droplets can collide and merge, gradually growing larger. These interactions are vital, as they help determine when cloud droplets may become heavy enough to fall as precipitation. The chaotic nature of this mixing process encourages growth, setting the stage for rain or snow to emerge from what once seemed like a soft, stable blanket of white. Clouds are dynamic entities, constantly shifting and morphing under the influence of these internal forces. The beauty of their ever-changing shape is a reflection of these intricate movements. Each ripple of energy within brings forth a new possibility, allowing weather patterns to evolve quietly overhead. The calm, continuous dance of these eddies reminds us of the complexity that exists within simplicity, as they contribute to the life cycle of clouds and the moisture they carry. The North Atlantic Oscillation, a subtle yet powerful climate pattern, weaves through the atmosphere, creating variations in weather that can be felt across the North Atlantic and into Europe. This oscillation operates on different timescales, revealing its complexity. Some shifts occur in a matter of days, while others can linger for years, even decades. These longer-term trends shape the fabric of the atmosphere over extended periods, molding the weather in ways that reflect the rhythm of the oscillation. As the phases of the North Atlantic Oscillation shift, they influence the paths taken by storms. These changes can either amplify or diminish the intensity of storms as they traverse the ocean and move toward land. This modulation affects not just temperature and wind patterns, but also plays a significant role in precipitation. Each phase of the oscillation brings with it distinct conditions, creating an environment that can encourage or deter cloud formation. Clouds themselves respond to these variations, with their development intricately linked to the prevailing weather patterns. As storm tracks shift and alter, the processes that lead to clouds growing, thickening, and eventually releasing rain follow suit. The gentle ebb and flow of the North Atlantic Oscillation harmonizes with the atmosphere, guiding the dance of moisture through the air. Over time, the interconnected nature of this oscillation and cloud formation illustrates a delicate balance, showing how the rhythms of the Earth's climate create a tapestry of weather that unfolds continuously, allowing nature to express its transient beauty. In the depths of the ocean, layers of sediments accumulate over vast stretches of time. These sediments, composed of tiny particles, shells, and remnants of living organisms, gently settle and create a soft blanket on the ocean floor. As centuries pass, the weight of these layers increases, pressing down on those beneath. This gentle compression builds a quiet pressure that begins to change the very nature of these sediments. As the layers pile up, the heat from the Earth's interior seeps outward, further influencing this transformation. The combination of pressure and heat initiates a slow process. Over eons, the sediments gradually alter into different types of rock, known as sedimentary rock. This evolving journey makes its way through the vast cycles of nature, embodying the rock cycle that shapes the Earth's surface. Every grain tells a story, carrying with it elements of its previous existence. The formation of sedimentary rock marks only one chapter in this ongoing cycle. When these rocks are uplifted, they may be exposed to weathering and erosion, breaking down once more into smaller particles. These particles can eventually be redeposited, beginning the transformation anew. As the cycles continue, rocks can also be subjected to even greater pressures, evolving into metamorphic rock, another stage in this continuous flow of geological change. In this serene transformation of materials, one can sense the slow, rhythmic dance of Earth's processes. The phases of compression, heat, and time intertwine, revealing the profound interconnectedness of our planet's geology, each layer patiently awaiting its turn in the cyclical journey. The delicate balance of these processes carries on seamlessly, nourishing the ongoing story beneath the waves, where time flows quietly and gently like the depths of the ocean itself. High above the Earth, clouds drift gently across the sky. Their movements are a quiet dance, influenced by the invisible currents of air surrounding them. These currents, known as wind patterns, flow steadily around the globe. The behavior of these winds can shift gradually over long periods, creating changes in how clouds traverse the sky. When wind systems experience subtle alterations, they can affect the speed at which clouds travel. For instance, if the prevailing winds in a region strengthen or weaken over time, clouds might begin to move more rapidly, or conversely, with more grace. This change can unfold subtly, often over thousands of years, shaping the rhythms of weather patterns without immediate notice. The formation and dispersal of clouds depend largely on the characteristics of the air they inhabit. Air that is warmer may offer less resistance, allowing clouds to glide more swiftly. Meanwhile, in cooler air, clouds can drift more slowly, gathering together, or perhaps dispersing into wispy strands. As these patterns shift, the landscape of the sky can transform. High-altitude currents, such as the jet streams, can play a significant role in this process. The jet streams can exert their influence on regional weather, guiding how clouds may cluster or scatter. Over time, these systems might shift slightly, leading to varied cloud patterns, some appearing almost stationary and others whirling by with a gentle haste. These changes, while imperceptible in day-to-day life, unfold with quiet persistence. Each cloud in its journey reflects the dynamic state of the atmosphere above, painting a picture of time and movement that is constantly in flux. Observing this gentle evolution can evoke a sense of peace as the clouds continue their endless journey against the backdrop of the vast sky, unhurried and free. Within the delicate embrace of the atmosphere, clouds are continually forming and evolving. These wondrous collections of tiny water droplets or ice crystals float gracefully, held aloft by air currents. Each droplet dances in the air, supported by the intricate balance of forces at play. As these tiny particles come together, they begin to grow, merging with others around them. As the droplets increase in size, they gather and collide in the cool air, slowly becoming heavier. Eventually, they reach a critical point where gravity begins to exert its gentle influence. This force, always present and steady, pulls the droplets down toward the earth. When they become sufficiently large, they cannot resist any longer. The droplets start to fall, and this is the beginning of precipitation. The journey of these droplets can manifest in various forms. When temperatures are warmer, they may fall as gentle rain, nourishing the ground below. As conditions shift and the air grows colder, the droplets can freeze into ice crystals, transforming into snowflakes that float softly to the earth, blanketing the landscape in white. In some instances, particularly where conditions are unstable, the droplets can become large enough to form hail, falling with a surprising weight. This life cycle of clouds and precipitation contributes to the ever-changing scene above. It not only connects the sky to the ground, but also plays an essential role in the water cycle. Each droplet that falls brings life and renewal, feeding rivers, lakes, and ecosystems. The gentle pull of gravity works continuously, guiding these tiny particles in their descent and shaping the rhythms of weather. As clouds release their offerings, they begin anew, rising back into the sky, ready to start the cycle once more, while the soft sound of falling rain or the quiet hush of snowflakes landing adds to the serene atmosphere of the world below. Over long periods, the nature of clouds subtly transforms, responding to the gentle ebb and flow of the atmosphere surrounding them. Each type of cloud has its own characteristics, shaped not only by temperature and moisture, but also by the changing composition of the air. Variations in the atmosphere, influenced by natural processes like volcanic eruptions or the shifting of tectonic plates, can introduce new particles and gases into the air, altering the delicate conditions that give rise to clouds. As these elements evolve, the reflectivity and water content of clouds may gradually shift. A cloud that once appeared bright and fluffy, reflecting sunlight with a vibrant glow, might evolve in appearance as the atmosphere changes. Its texture and color may dim, softening the brilliant whites to grays, reflecting the alterations in the surrounding environment. This transformation is slow and unhurried, unfolding over vast stretches of time as different layers of the atmosphere interact with each other. Changes in the composition of water vapor can also influence how clouds form and exist in the skies. Higher levels of certain gases may encourage clouds to hold more moisture or become denser, creating deep, layered formations. In contrast, other variations could lead to lighter, more fleeting clouds, drifting gently across the sky. This ever-present dance of elements creates a gentle cycle of transformation, a reminder of the interconnections that exist within our atmosphere. The clouds float above, adapting seamlessly, their subtle changes a testament to the shifting nature of the world around them. As they drift and change, they weave a serene tapestry across the sky, inviting the eye to linger and the mind to wander peacefully. The amount of cloud cover across our planet shifts gently over long timescales, influenced by the intricate dance of natural forces. Ocean currents act as silent architects of this change, as they move warm and cold water around the globe. When these currents fluctuate, they can alter the temperature and evaporation rates of seawater, stirring the atmosphere above. This in turn affects how clouds form and their extent across the skies. Volcanic activity also plays a significant role in cloud cover. When a volcano erupts, it can release ash and gases high into the atmosphere. These particles can encourage cloud formation by providing surfaces for water droplets to gather and coalesce. For years following such events, the amount of cloud cover over specific regions can rise and fall, reflecting the ongoing influence of the material released by the Earth itself. Over centuries, these changes intertwine with the rhythms of climate, subtly guiding the patterns of cloudiness across different landscapes. Dense clouds may blanket vast areas, while in other times and places, the sky may remain largely clear. This gentle ebb and flow contributes to the long-term climate patterns that shape our world. As these atmospheric conditions evolve, the visual experience of clouds shifts as well, creating varied landscapes in the sky. One moment, clouds may gather to form an expansive quilt, while at another, they may disperse, allowing blue skies to peek through. Each phase offers a quiet reminder of the dynamic nature of our environment. The processes move with deliberation, creating a soothing backdrop to the ever-changing tableau of the atmosphere, patiently shaping our world above. Within the tranquil realms of clouds, tiny water droplets and ice crystals drift through the air, floating gently in an otherwise peaceful environment. Though each individual particle carries no electric charge, their spirited movement can stir something remarkable in the atmosphere. As these droplets collide with one another, they engage in subtle yet dynamic interactions, causing them to shift and tumble. This relentless motion leads to a separation of electrical charges, even within the same cloud. Different regions within a single storm cloud can accumulate varying levels of charge, creating potential differences that linger as the cloud grows and evolves. The process is gradual, a quiet accumulation that occurs over time, often unnoticed by the world below. The interplay of temperature, moisture, and motion weaves a delicate tapestry of electrical energy throughout the cloud's body, deeply connected to its physical structure. As these storm clouds expand, the electrical potential can strengthen, resting beneath layers of neutral particles for long periods. It gently awaits the right moment to release this energy, which often happens through the breathtaking act of lightning. This stunning display is not a sudden outburst, but rather a culmination of a slow and intricate buildup, releasing energy in a brief luminous flash that momentarily illuminates the atmosphere. Following this discharge, the surrounding calmness returns, subtly reminding us of the nurturing yet powerful forces at play in the heavens. As time drifts on, clouds continue their dance, ever shifting, ever changing, in harmony with the larger symphony of our atmosphere, inviting us to breathe deeply and relax in their presence. The silence settles once more, a gentle lull in the vast expanse, ripe with potential. Within a cloud, the pressure embodies a delicate balance, closely mirroring the surrounding atmospheric pressure that envelops it. As air rises, it cools and condenses, forming clouds. Yet within this ethereal mass, subtle differences arise. The base of the cloud may experience slightly higher pressure due to the denser accumulation of water droplets and ice crystals, while the upper regions tend to have lower pressure as the air becomes less dense and cooler. These small variations in pressure weave a gentle tapestry that influences the cloud's movement and structure. When conditions allow for stability, the average pressure within the cloud remains fairly consistent. However, as air masses move and shift, gradual fluctuations can occur. These slow changes are often imperceptible as dynamic adjustments happen around them, creating a soothing rhythm that mirrors the tranquil nature of the cloud itself. Pressure changes can influence the formation of different cloud types, and their development over time. Yet, amidst these soft transitions, the core of the cloud maintains its quiet existence, floating serenely above the earth. Each moment brings with it a world of shifting air and water, enveloping the particles in a gentle embrace. As the night unfolds, the cloud continues to drift peacefully, perpetually shaped by the subtle dance of density and pressure. The air it holds gently circulates, carrying whispers of the weather patterns that connect all aspects of the atmosphere. The calm fluctuations within the cloud contribute to the soothing embrace of the sky, inviting a sense of stillness and restfulness. The gentle movement of wind holds a significant role in the life of a cloud, softly guiding its journey across the vast expanse of the sky. As currents of air form and shift, they carry clouds with them, shaping their appearance and altering their structure. Wind patterns can vary, from light, soothing breezes that barely stir the atmosphere, to more vigorous gusts that add energy to the scene above. These variations in wind speed influence how clouds are formed and transformed, creating a diverse array of shapes and textures. Wispy cirrus clouds, delicate and elongated, often dance high above, drawn out by the gentle touch of the air. These clouds reveal the delicate balance of moisture and temperature at greater altitudes. In contrast, the more robust cumulus clouds, resembling soft, puffy cotton balls, thrive in the embrace of stronger winds, growing larger as moisture accumulates. As the wind flows, it connects different layers of the atmosphere, transporting water droplets and ice crystals along with varying temperatures. This movement leads to ever-shifting formations, with clouds continuously morphing from one shape to another. The peaceful rhythm of air currents sustains their existence, allowing them to drift lazily, reforming while they travel onward. Over time, the journey of clouds reveals the subtle ebb and flow of nature's breath, gently reminding us of the connections that exist in the sky. Each shift in wind offers a continuation of their tale, softening their edges and changing their forms. The clouds float through an endless expanse, shaped by forces both gentle and strong, settling softly into the serene embrace of the night sky. The structure of clouds is a delicate tapestry of tiny water droplets and ice crystals, gently suspended in the air. Unlike solid objects, clouds lack a distinct core or sharp boundaries. Instead, their form seamlessly blends into the surrounding atmosphere. This diffused arrangement contributes to their soft, ethereal appearance, allowing them to drift and shift with the breezes above. Within a cloud, the particles are scattered throughout, creating a light and airy composition that gives these formations their unique ability to float. There is a gentle interplay between humidity and temperature as moisture gathers around small particles. This process keeps the cloud stable, preventing it from collapsing under its own weight. The absence of a solid structure adds to the cloud's tranquility as it floats gracefully through the sky. Despite their fleeting nature, each cloud holds a world of possibilities within its soft edges. The way the tiny droplets cluster and form layers contributes to the cloud's overall shape, resulting in an evolving structure that endlessly captivates the eye. The edges of clouds blend and dissolve, creating a sense of movement that is both calming and relaxing, yet also dynamic in its constant change. As different types of clouds emerge, their spread-out nature allows them to interact harmoniously with light. Soft beams filter through these airy structures, casting gentle shadows and illuminating their changing forms. Even in their ever-evolving state, clouds maintain a serene quality, a reminder of the beauty found in their simplicity. Each cloud drifts gently, embodying the peaceful rhythm of the atmosphere, ready to carry on with its journey through the expansive sky. Virga showcases a quiet yet fascinating aspect of the water cycle. This phenomenon occurs when droplets or ice crystals descend from a cloud, but meet drier air before they can reach the ground. As these particles drift downward, they create slender, wispy streaks that draw the eye. These streaks can appear delicate and ephemeral, drifting gracefully from the cloud base, only to disappear into the atmosphere before ever touching the surface. In regions where the air is particularly arid, the formation of virga becomes more common. The moisture from the falling precipitation evaporates, its journey cut short, leaving a gentle reminder of the cloud's presence high above. The wisps may linger for a time, capturing sunlight and casting soft shadows. The droplets dance through the atmosphere, highlights the transformation of water and nature, weaving between liquid and vapor as they float and fade. Observing virga can be serene, as it illustrates the delicate balances within our environment. The sight of these wispy trails can evoke a sense of calm, as they embody the transient nature of clouds and the air they inhabit. Each streak represents a moment of potential that remains safely suspended in the dry air, a reminder of the interconnectedness of the water cycle. The presence of virga serves to enrich the visual tapestry of the sky, a soft display of nature's ability to shift form. Its existence, though brief, adds a subtle layer to our understanding of atmospheric processes, inviting us to appreciate the quiet transformations occurring above us. In the midst of the sky's vastness, these gentle movements bring a peaceful reminder of the world's ongoing rhythms, waiting to unfold in a mesmerizing way. The El Niño Southern Oscillation represents a cycle that subtly influences the climate across the globe. At the heart of this phenomenon are the warm ocean waters of the tropical Pacific, which can fluctuate in temperature over periods of time. When these sea surface temperatures rise, we observe an event known as El Niño. Conversely, when these waters cool, it is referred to as La Niña. Each phase brings its own set of patterns and responses within the atmospheric system. As these waters change, they can affect cloud formation and rainfall distribution far beyond the Pacific. The warmth associated with El Niño can lead to an increase in moisture in the atmosphere, fostering cloud development that may result in altered weather patterns. This effect can extend across continents, subtly shifting where rain falls and how storms develop. The breathing in and out of this cycle occurs over the span of 2 to 7 years, each rhythm like a gentle sway in the natural world. At times, the interconnectedness of ocean and air can create unexpected weather scenarios, reshaping climates in ways that unfold quietly over time. As ocean temperatures fluctuate, the vast expanse of water serves as a conduit for change, guiding the ebb and flow of clouds and precipitation. La Niña, with its cooler waters, often brings dry conditions to certain regions, while simultaneously enhancing rainfall in others. This ongoing dialogue between the ocean and the atmosphere is a gentle reminder of nature's complexity. Each phase of the El Niño Southern Oscillation leaves traces in our weather patterns, influencing not just local climates, but also the global tapestry of weather systems. The cycle continues, unhurried and ever-present, weaving together the threads of the natural world in a soothing rhythm that is both dynamic and serene. Milankovitch cycles represent a soothing yet profound rhythm in Earth's movements through space. Over extensive periods, the planet experiences subtle changes in its orbit around the Sun, along with gradual shifts in its axial tilt. These variations occur over tens of thousands to hundreds of thousands of years, moving in slow, natural harmony with the cosmos. As Earth's orbit evolves, it alters the distance from the Sun, affecting the amount of solar radiation that reaches different parts of the planet. The axial tilt, which also changes, influences how sunlight is distributed across the seasons. These gentle oscillations contribute to the patterns of warming and cooling that many may experience in a broader sense, as they can change Earth's climate over long spans of time, guiding the dance of ice ages and interglacial periods. The long-term behavior of these cycles can lead to shifts in cloud patterns, modifying how moisture is held in the atmosphere. This transformation can impact precipitation rates and the persistence of clouds across various regions, weaving together a complex tapestry of climate change that unfolds gradually. Each cycle, while slow, establishes a delicate balance amongst the elements that coexist in the atmosphere and oceans. As Earth journeys through these variations in its orbit, the lush changes in climate gently take shape. They work harmoniously to influence what we call the natural world, creating a comfortable interdependence between light, air, and water. Each moment in this cycle echoes through time, reflecting the gentle persistence of nature's rhythm and reminding us of the quiet forces at play in a universe that is always in motion. The cycles linger like a soft whisper, a reminder of the slow dance of our planet as it travels through the embrace of stars. In tropical convergence zones, a unique interplay of elements creates a lush environment where cloud cover can persist for weeks at a time. Warm temperatures envelop this area, allowing moisture to gather steadily in the atmosphere. The heat from the sun warms the surface, encouraging water to evaporate from the oceans and land. This abundant moisture rises into the sky, where it begins to cool and condense, forming clouds. Regular atmospheric lifting plays a crucial role in this process. As warm air rises, it creates a gentle upward movement that sustains the clouds. This lifting is often enhanced by the convergence of trade winds, bringing together air from different directions. The meeting of these winds fosters a consistent environment where clouds can develop and thrive. The warm, humid air ascends, cooling as it reaches higher altitudes. This cooling leads to condensation, and the moisture gathers, thickening the clouds. Over time, layers of clouds can form, creating a soft, continuous blanket over the sky. These conditions allow clouds to linger, fostering a serene, overcast scene that is characteristic of these tropical regions. The persistence of the cloud cover contributes to a unique climate, where rainfall may be frequent but gentle, further nurturing the lush vegetation below. Each day in this zone can feel similar, with the clouds hanging gracefully overhead, creating a sense of tranquility. The clouds are gentle guardians of the landscape, floating softly in a steady embrace of warmth and moisture, inviting a calmness that lingers in the air, ready to envelop the listener into deeper relaxation. Ice crystals form delicately in the cool embrace of clouds, their growth influenced by the surrounding conditions. As these crystals develop, they experience internal stresses that arise from their interactions with other molecules in the environment. Each tiny crystal, unique in its formation, bears the gentle marks of these processes, creating a complex structure that changes gradually over time. The internal stresses within the ice crystals are a reflection of how they grow. This slow building pressure can shape their form, altering how they branch and expand. In some cases, these stresses may lead to fractures, creating smaller fragments that float softly among their larger counterparts. In other instances, the ice crystals may aggregate, joining together to form more complex structures. As the clouds continue to evolve, the interplay of these microscopic stresses plays a key role in shaping the cloud's overall appearance. Fluffy formations contrast with denser patches, each part telling a quiet story of the interactions occurring within. Over time, the atmospheric conditions may change, leading to a gentle release of these stresses. The ice crystals can shift, their delicate formations reorganizing as they drift and settle. The overall dynamics within the clouds reveal a deep, calm complexity. Small forces at play remind us how interconnected all elements in the atmosphere are, each crystal adding to the serene beauty of the sky. The clouds quietly embody this balance, their soft movements a testament to the delicate dance of ice and air, continually weaving through the unseen forces that govern their existence. Individual cloud droplets, though minuscule, possess a quiet complexity that evolves over time. These tiny bits of water or ice float gently in the atmosphere, each one experiencing subtle changes due to varying conditions around them. As they linger, they may gradually increase in size, absorbing moisture from the air or colliding softly with neighboring droplets. With each gentle interaction, they grow, transforming into slightly larger spheres of liquid or crystalline structure. The density of these droplets is not fixed. It is influenced by temperature fluctuations, humidity, and pressure changes occurring in the environment. On warm afternoons, for instance, the air swells with moisture, which invites droplets to expand. In such moments, they may become a little heavier, their density increasing gently. Conversely, as temperatures drop, these droplets may lose some of that warmth, allowing them to freeze or condense into a more compact form. Over extended periods, the gradual evolution of these droplets leads to subtle shifts within the cloud itself. This dynamic process occurs quietly, a slow dance of transformation that might go unnoticed in the larger tapestry of the sky. As the droplets evolve, they can cluster together, merging in soft elegance, while others might drift apart, each taking its own path, contributing to the unique and ever-changing shapes of the cloud. The delicate balance of these processes reveals a serene interplay as the atmosphere continuously shapes and reshapes the individual components within it. Such transformations are a testament to the calm rhythm of nature, reminding us of the lasting yet gentle influence of the environment. Amidst all these changes, the clouds persist, existing in a state of quiet beauty, ready to evolve further as the world around them shifts ever so slightly. Cirrus clouds are delicate formations, a composition of tiny ice crystals that float gracefully in the upper reaches of the atmosphere. Here, the temperatures are strikingly low, often well below freezing, creating an environment where these ice crystals can thrive. In such conditions, moisture is sparse, allowing the ice to remain unchanged for extended periods. This stability contributes to their ethereal presence, allowing them to linger quietly in the sky. The formation of cirrus clouds is a gentle process. As water vapor rises and cools in the upper atmosphere, it transforms into ice crystals almost seamlessly. These crystals, once formed, do not quickly dissipate or evaporate. Instead, they slowly drift and settle, becoming part of a broader tapestry of clouds. Their enduring nature can often lead to beautiful, wispy patterns that stretch across the sky, captivating the eye with their elegance. The interaction of these ice crystals with the atmosphere around them is subtle yet fascinating. Even as they exist in an environment with low moisture, the ice crystals can slowly sublimate, occasionally returning to vapor. Yet, this vapor doesn't always leave their structure entirely. Some will replace lost crystals, preserving the cloud's composition. Thus, change happens in a gentle cycle, an unhurried dance that reflects the calmness of their surroundings. Cirrus clouds may occasionally witness shifts in weather conditions, yet they persist, maintaining their presence with quiet resilience. The interplay of temperature and moisture encapsulated in this high-altitude realm allows for a serene coexistence of ice crystals suspended within an endless expanse. Each moment, the cirrus clouds embody a tranquil state that hovers before us, unwavering and poised, ready to continue the journey of their delicate existence in the vast sky above. Noctilucent clouds drift quietly in the mesosphere, a region far above the surface of the Earth. These clouds have a unique glow, shimmering softly against the twilight sky. Their ethereal beauty arises from the delicate ice crystals that compose them, catching the faint light of the sun during the brief moments when day meets night. Only at twilight do these clouds reveal themselves, as the sun dips below the horizon, illuminating their form with a soft sheen. The formation of noctilucent clouds is a result of specific atmospheric conditions. Here in the mesosphere, temperatures are exceedingly low, providing a cool, stable environment for the water vapor to freeze into ice. These structures remain suspended in the atmosphere, high above the weather systems that govern lower altitudes. Their existence is subtle, yet they mark a fleeting moment each evening, a gentle reminder of nature's quiet phenomena. Recently, these clouds have been appearing more frequently and with greater luminosity. Climate change appears to be influencing their patterns, linking their frequency to changes in atmospheric conditions. As temperatures shift, the delicate balance that allows these clouds to form may be adjusting as well, impacting their presence in the night sky. Each night, as twilight approaches, the conditions may align perfectly for these shimmering clouds to emerge. They float silently, like fragile dreams made tangible in the cool dusk. Observing them invites a moment of calmness, a connection to the vastness of the sky and the intricate workings of our planet's atmosphere. The soft, glowing forms linger briefly before fading away, leaving a tranquil space where the mind can rest, and the cosmos continues its quiet dance, ready to unfold its next chapter in the serenity of night. Within the gentle embrace of a cloud, sunlight interacts with countless water droplets and ice crystals, creating a delicate balance of energy. As sunlight penetrates the cloud, it is scattered and redirected in many directions. This scattering occurs as the light encounters the tiny particles suspended in the cloud, each one absorbing energy selectively before re-emitting it. This process happens continuously, with energy moving back and forth between the cloud's water droplets and the ice crystals. Each droplet or crystal plays its own role, absorbing sunlight and then radiating it again, often in different directions. The interaction of light with these particles can influence the overall temperature within the cloud. The energy redistribution contributes vastly to the thermal characteristics of the cloud, affecting its stability as well. When energy is absorbed, it warms the droplets, which might then change how the cloud forms or persists in the atmosphere. A well-balanced cloud structure may lead to a more stable formation, while excess energy can create instability, potentially leading to the cloud's dispersal or transformation. This intricate dance of light, energy, and particle sizes ensures that clouds remain dynamic entities, ever-changing and alive with subtle movements. The radiative process continues quietly, layering warmth or coolness within the cloud, shaping its identity in real time. Through this continuous interaction of light and particles, clouds reflect the ever-shifting nature of the atmosphere itself, a soft reminder of the interconnectedness that exists within the natural environment. Each droplet and ice crystal plays a part, working together to foster the gentle presence of clouds in the sky, enveloping the world beneath in a serene comfort, ready for the next gentle whisper of twilight. Over long stretches of time, the atmosphere experiences a gradual and consistent evolution. This change occurs through various natural processes, such as volcanic activity and the influence of living organisms. Volcanic eruptions release gases like carbon dioxide and sulfur dioxide, slowly altering the composition of the air surrounding the Earth. Each release introduces new elements, affecting the delicate balance of the atmosphere and transforming it over millennia. Meanwhile, the role of biological processes cannot be overlooked. Plants, algae, and other living organisms contribute to the atmospheric shifts as they carry out their life processes. Photosynthesis, for example, produces oxygen as a byproduct, steadily increasing its presence within the atmosphere. Over geological time, the concentration of this vital gas has fluctuated, guided by the rise and fall of plant life, along with the global climate and environmental conditions. These oxygen variations create a dynamic interplay in the air we breathe, where changes can significantly impact what exists on Earth. Life itself has evolved in response to these shifts, adapting and thriving as oxygen levels altered, allowing for the diverse ecosystems we observe today. As time flows onward, scientific exploration reveals the complexity of these atmospheric transformations, showing how they weave together the history of our planet. The atmosphere remains a living, changing entity, continuously shaped by natural forces in a gentle, slow rhythm. Clouds drift above, sometimes thick and heavy, sometimes light and wispy, signaling the ongoing dance of gases and elements that make up the world around us, ready for further exploration beyond the horizon. Mammatus clouds are intriguing formations, hanging gracefully from the underside of larger cloud structures. Their bulbous shapes, resembling pouches or sacs, often capture the attention of those who look up after a storm. The process that leads to their creation is both gentle and fascinating. When cold, moist air subtly sinks into surrounding drier air, the temperature differences and humidity levels combine to form these distinctive shapes. This descending air interacts with the existing cloud structure, creating pockets that protrude downward. It is a quiet dance of atmospheric conditions, where warm and cool air coexist in delicate balance. The cool, moist air descends in a manner that allows it to hold its shape, nurturing the formation of mammatus, which can sometimes linger long after the main thunderstorm has moved on. These clouds can provide a brief moment of stillness in an otherwise tumultuous sky. Their presence indicates a rich and variable environment where the air is constantly moving and changing. Over time, as the weather patterns shift, the graceful forms of mammatus clouds might fade, transitioning seamlessly back into the vastness of the atmosphere. Even as serenity returns, remnants of their beauty remain, hanging in memory and in the air. They serve as a reminder of the intricate processes occurring above us, a soft whisper of the atmosphere's complex nature. In the quiet observance of these celestial shapes, one can appreciate the ongoing story of the skies, inviting curious eyes to explore the wonders yet to come. Clouds present a fascinating array of optical properties that play a significant role in how they interact with sunlight. Among these properties, albedo stands out, reflecting the amount of light that has bounced back into space. This reflective quality varies depending on the composition of the cloud, influenced by the size of the water droplets or ice crystals that compose it. Larger droplets tend to scatter light differently than smaller ones, creating subtle variations in brightness. Transmissivity, another important characteristic, refers to how much light can pass through the cloud. Dense clouds filled with a multitude of tiny droplets allow less light to filter through, creating darker skies beneath them. Conversely, thinner clouds with larger gaps can be quite luminous, illuminating the sky with a soft glow. These optical properties are not static. They gently change with shifting cloud patterns throughout the day and across seasons. As clouds evolve, so too do their characteristics, subtly altering the energy balance of the Earth. The interplay between light and cloud determines how much sunlight reaches the surface, contributing to the warmth of a sunny day or the coolness of an overcast afternoon. Gradual shifts in cloud formation can indicate larger patterns within the atmosphere, and even the smallest changes in density or phase can influence how clouds appear. This dynamic nature of clouds holds a mirror to the ever-changing environment, reflecting the continuous flow of energy and light. Embracing the serenity of cloudy skies, one can find comfort in their gentle alterations as they quietly shape the world around us, patiently waiting for more stories to unfold in the vast expanse above. Within the delicate realm of clouds, the density of liquid water plays a pivotal role in their formation and structure. Typically, this density ranges from 0.1 to 1 gram per cubic meter, a gentle balance confined by the atmospheric conditions present at any given moment. The intricate dance of temperature and pressure governs this phenomenon, shaping how clouds develop and change over time. When clouds form, tiny droplets of water coalesce around minute particles in the atmosphere, such as dust or salt. These droplets remain suspended, creating a soft veil across the sky. The density of liquid water within clouds reflects the amount of moisture they contain, which is encapsulated within the gentle air currents that swirl around them. Higher densities may suggest a more substantial presence of water, yet they require specific conditions to be maintained, which are rarely observed. As air rises and cools, the water vapor may condense, forming droplets that share a delicate balance with the air surrounding them. Each droplet is a small world of its own, caught in a tranquil ballet. The composition of clouds shifts throughout the day as variations in temperature and humidity influence their density. Light breezes may gently lift these droplets, while stillness allows them to cluster together, swirling in harmony. The serene nature of cloud formation echoes an ongoing equilibrium in the atmosphere. Each cloud holds its own unique character, reflecting the complexity of the air around it, while remaining within the comforting constraints of its density. Observing the gentle flow of clouds can evoke a sense of tranquility as they continue to drift and evolve, ready to share soft glimpses of the world above. Within the gentle embrace of clouds, the presence of very fine dust particles and salt from the ocean plays a significant role in their formation. These tiny particles float delicately through the air, creating a myriad of opportunities for the water droplets within clouds to take shape. Known as cloud condensation nuclei, these seeds are always present, quietly waiting to join in the process of cloud creation. As water vapor rises into the atmosphere and cools, it seeks these tiny particles, gravitating towards them in a soothing dance. When water vapor encounters a dust particle or a grain of salt, it can begin to condense, forming droplets or even ice crystals, depending on the temperature. Each droplet originates from a small series of gentle interactions, merging air and moisture with the faint essence of dust. The presence of these particles ensures that clouds can sustain their delicate structure. They provide the necessary surfaces for moisture to collect and gradually grow. As more water vapor condenses onto these nuclei, droplets begin to gather, creating a gentle sense of completeness within the cloud. The size and composition of these particles can vary, but they remain integral to the formation and maintenance of clouds. supporting the harmonious interplay of water, air, and temperature. Continuously, as the clouds drift, these seeds of condensation persist within them, always ready to engage in the quiet process of transformation. Clouds evolve and shift, shaped by the ever-changing atmosphere, yet the presence of these tiny particles remains a constant, ensuring that the cycle of cloud formation continues in a soft and serene rhythm, ready to explore the next stage of their journey. Enveloping the earth in a gentle embrace, fog arises as a soft manifestation of stratus clouds hovering at ground level. This captivating phenomenon often occurs in valleys and coastal regions, where the atmosphere quietly balances cool temperatures and high humidity. Such environments provide the perfect conditions for fog to linger, creating a serene blanket over the landscape. During periods of calm, the air remains still. The soft movement of winds is hardly felt, allowing the fog to settle and persist undisturbed. A stable inversion layer, a warm layer of air trapping cooler air beneath it, also plays a crucial role. This layer prevents the fog from rising and dissipating, allowing it to stretch out comfortably across the ground. In these circumstances, fog can hold its form for days, wrapping around trees and buildings, softening sharp edges and sounds. As the fog swirls and shifts, it interacts gently with the surrounding air, forming tiny droplets of water, each sustaining its existence within the cool atmosphere. The presence of these countless droplets creates a soothing haze, blurring the line between earth and sky, inviting a sense of peace to settle in. With the atmosphere rotating slowly in this delicate balance, the fog provides a comforting and quiet experience, welcoming the subtle sounds of nature underneath its patient layers. In moments where the air remains undisturbed, the fog invites an extended presence, a gentle reminder of nature's ability to shape our surroundings with tender care. It rests within valleys or along coastlines, resilient against the march of time, harmonizing with the elements and gracefully awaiting the next changes in the atmosphere, while offering continued tranquility to those who might find themselves beneath its gentle hold. The Earth's magnetic field, a vast and invisible shield, experiences a soft ebb and flow over the course of thousands of years. Within this quiet cycle, there are periods when the magnetic field weakens, followed by phases where it regains its strength. This natural rhythm unfolds slowly, like the gentle tides of a secluded shore, reminding us of the planet's dynamic nature. During these fluctuations, the capacity of the magnetic field to protect the Earth from solar radiation can vary. When the field weakens, it becomes less effective at deflecting charged particles emanating from the sun. These particles, known as solar wind, can interact with the Earth's atmosphere in ways that alter its delicate balance. Over long spans of time, these interactions may influence the appearance of the sky, the distribution of energy within the atmosphere, and the patterns of life that thrive below. As the magnetic poles shift and realign, the planet undergoes subtle changes. The magnetic field serves as a constant reminder of the interplay between Earth and the cosmos, a protective barrier that varies in its strength but remains an essential companion in the journey through space. The cyclical nature of this field creates a sense of continuity amid the slow churn of geologic time, where each fluctuation contributes to the unfolding narrative of the planet itself. In the quiet of night, one can reflect on this rhythm, an invisible dance occurring high above, while the Earth rests comfortably below. The magnetic field, with its gentle variations, continues its steady presence, existing as a part of the vast tapestry of natural phenomena, forever shaping our world as it journeys through the cosmos. Mountain ranges, once towering and majestic, undergo a slow and gentle transformation over the span of thousands of years. Wind and rain, two quiet forces of nature, work tirelessly to erode the sharp peaks that once defined the skyline. Each breeze carries small particles away, while rainwater seeps into the cracks, steadily breaking down the strong granite and other rugged minerals. This soft, persistent action weaves a story of change, gradually blunting the once craggy heights and reshaping the landscape. As time flows like a serene river, the high and mighty mountains yield to the elements. The steep cliffs, which once seemed eternal, begin to surrender their sharp edges, becoming softer and more rounded. This slow wearing down creates a tapestry of rolling hills, where once there were jagged ridges. Valleys develop, cradled between the remnants of mountains, becoming lush and inviting as sediment settles into gentle slopes. Through this ongoing process, the land reveals itself, transforming the dramatic into the tranquil. Water, in its very essence, carries away fragments of rock that tell tales of the Earth's history. This unseen journey of erosion leads to the gradual leveling of peaks, creating a landscape that is rich with stories of time and patience. The soft undulations of the hills evoke a sense of calm, an invitation to connect with the rhythm of the Earth's slow transformations. Erosion continues, unhurried and gentle, weaving together the features of the land in a quiet, reassuring manner. The mountains, though diminished, remain an integral part of this ever-changing scenery, whispering the secrets of their past as they silently await the next chapter of their existence. In the cool embrace of the atmosphere, clouds drift gently through the air, some harboring the delicate presence of ice crystals, found primarily at higher altitudes, where temperatures are consistently low. These tiny formations hold a special place in the sky. As the sun sets and daylight fades, the air cools slightly, providing an ideal environment for these crystals to take shape. The formation of ice crystals is a slow dance where tiny water droplets freeze and begin to grow. They change their form gradually, taking on intricate designs, each an expression of the atmospheric conditions around them. As they collect water vapor from the surrounding air, their shapes evolve. The process is peaceful, marked by subtle shifts rather than abrupt changes. These crystals remain suspended in the air as long as the temperature stays beneath freezing, allowing them to sparkle quietly in the soft embrace of the cold. They may cluster together, forming intricate patterns that float softly. The icy structures can vary from slender needles to delicate six-sided petals, each unique in its silent journey through space. As they coexist with other droplets, they contribute to the overall character of the cloud. Some crystals, after a time, may begin to fall slowly to the ground, transforming into snowflakes, joining others on their descent. In this endless cycle of formation and transformation, these ice crystals linger in the sky, embodying a calm stillness, awaiting the conditions that will guide their path. The atmosphere continues to weave its gentle tapestry as crystals come and go, forever part of the grand ballet of the natural world. In the vastness of the atmosphere, a delicate balance exists that allows clouds to form and thrive. Among the intricate processes of cloud formation, condensation nuclei play a crucial role. These tiny particles, often composed of dust, salt, or smoke, serve as the seeds upon which water vapor gathers and condenses. When these particles are abundant, the air becomes a canvas for transformation, as water vapor clings to them, coalescing into droplets that gradually grow into clouds. However, the situation shifts when atmospheric pollutants come into play. Certain substances can limit the availability of these essential nuclei, creating a barrier to cloud formation. itself adrift, with no surfaces to latch onto. It remains in a gaseous state, unable to complete the transition into liquid droplets. The atmosphere becomes a quiet, unyielding expanse, where clouds may struggle to form. In this altered environment, the dynamics of weather change. The usual dance of vapor and condensation slows down, leaving patches of sky devoid of the soft shapes of clouds. Instead, the skies may appear more open, perhaps with a few isolated clouds that manage to find enough nuclei to flourish. This lack of cloud cover can create a serene, clear blue expanse, yet it also highlights the complex interplay of natural elements. In time, as conditions vary and the atmosphere shifts, new particles may emerge. Dust stirred by gentle winds or the remnants of other natural processes can introduce opportunities for condensation once again. The balance of the atmosphere continues to evolve, fostering cycles of formation and stillness. Each moment brings the potential for change, as the air carries the remnants of particles, waiting for the right conditions to reignite the cycle of cloud formation. The sky remains an open space, patiently anticipating its next transformation. The atmosphere is a tapestry of clouds, each one with its own unique characteristics, shaped by altitude and the composition of the air around it. Cirrus clouds, those delicate wisps high above, often float at altitudes that dip into sub-zero temperatures. As they assemble, their icy structures form intricate patterns, reflecting the sun's light in soft, subtle shades. In contrast, the more robust cumulus clouds, with their billowing forms, tend to hover at levels where temperatures remain comfortably above freezing. They thrive in warmth, expanding and rising, their temperatures gently fluctuating as they gather moisture from the surrounding air. This atmospheric warmth allows them to thrive, embracing the water vapor that transforms into droplets within their fluffy outlines. As time passes, the temperature of clouds can change gradually, a slow dance dictated by the environmental factors surrounding them. During the day, sunlight plays a crucial role, bathing clouds in warmth that penetrates their edges and encourages growth. As evening settles in, the cooling atmosphere pulls temperatures down, influencing the droplets within. The ever-shifting conditions above create a constant transformation within these airy entities. As clouds drift and interact, the interplay between heat and cold continues to shape them. The introduction of cooler air can lead to thickening, while gentle warming may encourage them to disperse. This slow evolution highlights the dynamic nature of clouds, responding harmoniously to the subtle shifts in their atmospheric home. Each cloud, whether delicate and frosty or warm and full, dances with the air, reflecting the ongoing changes around them. The sky remains a fluid expanse, inviting the dance of temperature and composition to unfold further. Within the gentle embrace of a cloud, the internal spaces are filled largely with air, creating a soft cushion that holds its delicate structure. This air, primarily composed of nitrogen and oxygen, mirrors the composition of the atmosphere that surrounds us. It becomes an integral part of the cloud's very essence, supporting and nurturing the fine droplets of water or ice that dance within. As clouds gather moisture, the air contained within them plays a crucial role. This mixture flows gently, allowing for the movement and interaction of tiny water droplets that float within, suspended in a soft ballet. The air creates a space where fluctuations in temperature can influence these droplets, sometimes leading to condensation or even the formation of precipitation. This ongoing process maintains a constant volume throughout the cloud, balancing the strength of the internal air currents with the external forces of the atmosphere. The relationship between the air and the water within is serene, operating in a cycle that harmonizes with the larger system of the sky. As the cloud drifts along, the air inside continues to ebb and flow, affected subtly by changes in temperature and pressure, and the tranquil harmony within sustains the structure, with the nitrogen and oxygen ensuring that even as the cloud shifts, it holds its form. This gentle coexistence of air and moisture allows each cloud to exist as a unique entity, constantly evolving, yet forever connected to the atmospheric rhythm surrounding it. There remains an endless cycle of subtle changes, echoing the calmness of the vast sky above. The shape of a cloud can drift and alter, shifting softly as it moves through the sky. Yet beneath these changing outlines lies a consistent composition that remains stable. The tiny droplets of water and sometimes ice encapsulated within the cloud are a constant presence, quietly existing amidst the air. Each droplet, no matter how small, contributes to the overall structure, adding weight and density to the soft, fluffy form. As the cloud sweeps through different altitudes and temperatures, the fundamental materials, air and water, persist. The arrangement of these droplets may evolve, some merging into larger ones, while others break apart, but the essence of the cloud remains intact. This fluidity is a natural consequence of the gentle dynamics occurring within. The water droplets interact harmoniously, allowing for a balanced atmosphere where evaporation and condensation can subtly take place. The air that cradles these droplets helps maintain the cloud's overall integrity. It supports the delicate dance of water, promoting a soft, serene environment where transitions happen slowly, almost imperceptibly. The relationships between each droplet, the air, and the cloud itself create a comforting environment where stability exists even amidst change. Thus, while the form of a cloud may slowly morph, the fundamental components, air and water, continue steadfastly. This ongoing interaction creates a peaceful equilibrium, nurturing the cloud as it floats through the expansive sky, an ever-present symphony of nature that remains both stable and fluid in its existence. Roll clouds, with their elongated tubular forms, gently unfold across the sky, creating a serene spectacle of nature's artistry. These clouds tend to hang at a distance from the larger cloud formations, appearing almost free-floating, gracefully aligned along a horizontal axis. Their shape evokes a sense of calm, flowing smoothly as they travel through the atmosphere. Typically, roll clouds are found at the leading edge of rain showers or the outflow from thunderstorms, hinting at the complex dynamics occurring within the larger weather system. As they drift along, they can cover extensive distances, often traveling for many miles. This movement reflects the gentle currents of air guiding them, much like a soft stream winding its way through the landscape. The air surrounding these clouds plays a crucial role in their presence and behavior. As warm air rises and cooler air shifts in to replace it, the interactions produce various cloud patterns. For a roll cloud to form, the conditions must be just right, allowing the warm moisture to mingle with cooler air, crafting that unmistakable shape that rolls so elegantly before the rain. The detached nature of roll clouds brings forth an intriguing sense of separation from the storm, even as they herald the approaching weather. Their gradual movements invite observers to experience the soothing rhythms of the sky, a reminder of the delicate balance in our atmosphere. Each roll cloud tells a story of air currents and moisture, weaving through the canvas of the sky, yet remaining comfortably still in their formations. The tranquility of watching these clouds drift can evoke a deeper sense of peace, inviting a moment of calm in the natural world. The atmosphere around us is a gentle force, shaping the clouds that drift above. pressure plays a significant role in the formation and characteristics of these cloud formations. When the atmospheric pressure is higher, it exerts a compressive force on the air as it rises. This compression can lead to the development of clouds that are more compact, giving them a denser appearance. These clouds may gather quickly, forming robust structures that can even hint at the potential for impending weather. Conversely, when the atmospheric pressure is lower, air has the freedom to expand. This expansion allows the air to cool, which is essential for cloud formation. As the air cools, moisture within it condenses into tiny water droplets or ice crystals, gradually coalescing into the soft, fluffy formations we often admire. In this delicate dance, clouds might take on a lighter, more ethereal quality, drifting lazily across the sky. The continuous interplay between pressure, temperature, and moisture creates a beautiful tapestry of clouds, each unique in its form and behavior. As different pressure systems influence the air around them, clouds evolve, appearing and disappearing like whispers in the wind. Observing these transformations can bring a sense of peace, as one realizes that the environment is ever-changing, yet entirely balanced in its processes. Each cloud reflects the conditions of its existence, shaped softly by pressure and temperature. The gentle fluctuations in the atmosphere orchestrate a symphony of clouds, reminding us of the simple, intricate workings of our natural world. These formations, whether compact or expansive, continue to roll softly across the skies, waiting, shifting, and unfolding in their quiet dance. Clouds exist as dynamic systems where not only the physical shapes, but also the chemical makeup of their rain undergoes gradual transformations over time. Within these clouds, atmospheric gases continuously interact. Changes in the levels of carbon dioxide, sulfur dioxide, and nitrogen oxides can lead to subtle variations in the precipitation that eventually falls to the ground. Such alterations may affect the acidity of the rain, shifting it gently from neutral to slightly acidic, or even more alkaline, depending on the balance of these gases. The process is slow, unfolding across days, months, and even years. As these gases dissolve in the droplets of water within clouds, they interact with the water molecules themselves. These interactions can alter the chemistry, leading to a delicate balance in the rain's properties. Such changes are often imperceptible in the short term, yet over many cycles of evaporation and precipitation, the impact accumulates, reflecting the overall health of the atmosphere. Rain is not merely a collection of water droplets, it is a bearing of information about the environment it descends from. As the clouds evolve under the influence of changing atmospheric conditions, so too does the nature of the rain they release. Each drop carries the essence of the air that surrounded its formation, encapsulating the whispers of the atmosphere. This quiet transformation of chemical makeup allows us to understand the deep interconnectedness of our atmosphere, illustrating how every element within it dances together over time. Each gentle rain contributes to a complex story, revealing the subtle yet significant rhythms of nature. In this continuous cycle, the clouds and their rain remain beautiful reminders of the delicate balance of our world, ever evolving while remaining gracefully constant. In a stable atmosphere where vertical air movement is minimal, the sky can be adorned with large, featureless sheets of cloud, such as altostratus. These clouds stretch across the horizon, creating a smooth, uniform appearance that can linger for many hours, even days. The softness of their texture contrasts with the sharper edges of more turbulent clouds, reflecting a tranquil state in the sky above. The stability of the atmosphere plays a crucial role in the formation and persistence of these wide, smooth sheets. When air moves gently, without much upward or downward motion, the clouds can develop in layers, gently overlapping one another. Each layer interacts with the other, allowing moisture to remain suspended without the disruption caused by winds or thermals. This creates an environment where the cloud can maintain its cohesion, remaining relatively unchanged. Such clouds often signal a type of weather that is influenced more by gradual changes rather than sudden shifts. The moisture within these altostratus formations is dispersed evenly, allowing the cloud to absorb warmth from the sun and radiate a gentle light across the landscape beneath. When the atmosphere holds this steadiness, it provides a backdrop of calm that envelops everything below. This enduring cloudiness can evoke feelings of coziness and comfort, preserving the gentle atmosphere that defines those tranquil days. As time passes, the clouds may slowly evolve, thickening or transitioning, yet their presence can feel like a constant, soothing reminder of the stability in the natural world. In this serene embrace of the sky, the quiet beauty of altostratus clouds offers a space where the day can unfold softly and undisturbed. Clouds, in their gentle, billowy forms, are composed of countless tiny water droplets or ice crystals. Each droplet is so small and light that it can effortlessly float in the air, suspended within the vast expanse of the sky. These delicate particles are ever present, forming a visible mass that can take on various hues and textures, depending on the amount of sunlight filtering through. The formation of clouds begins with the cooling of air that holds moisture. As this air rises and cools, the water vapor condenses around tiny particles known as condensation nuclei, creating droplets. When many of these droplets congregate, they create a cloud. Their collective lightness allows them to linger in the atmosphere, dancing softly as they are gently moved by faint currents of air. The process is slow and almost serene, with each droplet reflecting light in subtle ways, often giving clouds their characteristic brightness or softness. Despite their apparent fragility, these tiny droplets have a remarkable ability to cluster together, forming the thicker layers we see in the sky. The interplay between temperature and moisture determines how these droplets behave, allowing some clouds to remain wispy and thin, while others can expand into dense, billowy formations. Ice crystals may also play a role, especially in colder conditions, providing a different texture and appearance to the clouds. As the environment around these clouds changes, so too can their structure and visibility. Some may drift apart, while others can merge into larger formations, showcasing the constant and gentle movement of the atmosphere. Throughout this tranquil dance, the simple presence of water droplets and ice crystals reminds us of the delicate balance within the natural world, where each tiny particle floats onward, contributing to the overall beauty of the sky. Clouds have a way of lingering in the sky, their forms sometimes present for many hours or even days. Yet, beneath this seemingly stable appearance lies a dynamic process shaped by the gentle movements of the atmosphere. Atmospheric circulation patterns slowly shift and change, guiding the cloud formations through a gradual journey. These patterns of wind and temperature play a role in determining the fate of each cloud. When winds shift direction or when temperatures fluctuate, the very fabric of the cloud can begin to change. This evolution occurs so subtly that it might escape immediate notice. Over time, the cloud may become thinner, with some droplets evaporating into the air, while others might drift away, carried by a soft breeze. In contrast, a cool shift in temperature can cause more moisture to join a cloud, thickening its texture and enhancing the layers. These transitions, while gentle, can lead to remarkable transformations. A cloud that once floated peacefully may gradually dissipate, its droplets scattering into the atmosphere. Conversely, a gathering of clouds may merge and expand, forming a denser structure. Each cloud's life is a continuous cycle of formation and dissolution, influenced by the unseen rhythms of the atmosphere. As these slow changes unfold, the appearance of the sky evolves with them, creating a serene tapestry of light and shadow. The presence of clouds is a reflection of this ongoing dance, a reminder of the delicate balance of elements at play within the sky. The gradual adjustments in winds and temperatures guide the cloud formations, allowing them to flow into new shapes and forms as they gently traverse the vast expanse above us. Lenticular clouds emerge in a distinct, lens-like shape, often finding their place over mountain ranges. Their form is a gentle reminder of how air interacts with the natural contours of the earth. As winds flow over the peaks, they create a wave-like movement in the atmosphere. The moist air rises and cools, leading to the formation of these unique clouds, which can appear as though they are balancing delicately atop the mountains beneath them. Their stationary quality is quite remarkable. Even when faced with strong gusts of wind, lenticular clouds remain firmly in place, creating a striking contrast against the dynamic sky surrounding them. This stillness can lend them an otherworldly quality, leading some to gaze up in wonder and perhaps even mistake them for something beyond the realm of natural phenomena. The gentle, rounded edges of lenticular clouds can give them an almost sculptural presence, one that invites a serene contemplation of the sky. As they hover, they can catch and reflect the sunlight in different ways, imbuing them with shades that shift from soft whites to deeper grays, depending on the light conditions. Watching these clouds unfold can be a calming experience. They often signal clear air ahead, offering a moment of tranquility amid changing weather. The presence of lenticular clouds can inspire a sense of peace, their shape and stillness encouraging reflection. In this atmosphere, the world seems to pause, allowing thoughts to drift like the clouds high above, softly drawing one into the comforting embrace of the night. The gentle embrace of Earth's gravitational pull extends to every droplet of water and particle of ice suspended within a cloud. This force, while subtle in its individual effect, has a profound impact on the cloud as a whole. Each tiny droplet, influenced by gravity, contributes to a collective downward pressure that gradually shapes the cloud's existence. As the droplets cluster together, they begin to interact, merging and growing larger. In this thriving environment, gravity ensures that they do not remain suspended indefinitely. Instead, the internal dynamics foster a continual process of coalescence, allowing the droplets to gather the moisture contained within the cloud. And the delicate dance of these water droplets creates varying degrees of density within the cloud itself. As they grow heavier, the force of gravity becomes increasingly influential. The cohesive pull of the earth encourages these droplets to begin their descent. When enough of them come together and reach a critical size, the cloud releases its bounty, resulting in precipitation, whether as soft rain or delicate snowflakes. This gentle journey from cloud to ground is shaped by the underlying force of gravity, orchestrating a seamless transition through the atmosphere. In this process, the cloud transforms, losing its wispy form as it delivers essential moisture to the earth below. The rhythm of formation, growth, and eventual release is a testament to nature's quiet cycles. The understanding of these dynamics fosters appreciation for the serenity that clouds provide. Watching them drift slowly above can be a comforting reminder of the connections that persist in our world, inviting relaxation and reflection in the stillness of the night. Within the soft embrace of a cloud, water vapor resides, an invisible form of water that dances quietly in the atmosphere. This vapor, though not seen by the naked eye, plays a vital role in the cloud's existence. It occupies the space between the tiny droplets and ice particles, contributing to the cloud's intricate structure. The constant movement of this vapor is a seamless part of nature's rhythm. As temperatures within the cloud shift, the water vapor undergoes subtle transformations. When conditions are just right, it begins to condense into tiny droplets, creating the visible aspect of clouds. These droplets gather around microscopic particles, forming clusters that rise and fall gently, affected by varying temperatures and pressures. Despite the changes occurring around it, the vapor itself persists, existing in a continual state of flux. Humidity and temperature fluctuate, and this delicate balance shapes the cloud's density and formation. Often the vapor returns to its gaseous state, only to condense once again when conditions permit, maintaining an ongoing cycle. The intricate dance of vapor condensing into droplets and returning to vapor creates a layer of complexity within the cloud. Each cycle of evaporation and condensation contributes to the cloud's life, fostering an atmosphere of continual transformation. The associated movements of water particles create a serene environment, rich with the promise of rain or snow. Observing this silent ballet overhead can invoke a sense of calm. This gentle process signifies a natural order, weaving through the quiet expanse of the sky, fostering the layers of tranquility that allow for reflection. Each moment, each droplet, quietly flows into the next, completing a larger, comforting cycle in the vastness above. Heat transfer through convection plays a serene yet crucial role in the formation of clouds. In a calm atmosphere, when air warms, it becomes lighter, allowing it to rise gently through cooler layers above. This warm, moist air carries with it minute particles of water vapor, invisible to the eye, floating along as it ascends. As the air rises higher, it encounters decreasing temperatures. With this change, the warm air begins to cool and expands, creating a gradual transformation beneath the surface. As the moisture-laden air cools, the water vapor reaches its capacity, bending gently towards condensation. Tiny droplets, too small to see individually, form as the vapor clusters together around microscopic airborne particles. This delicate process unfolds in layers. The rising and cooling air forms the foundation of cloud development, shaping the ever-changing patterns that drift across the sky. It is a quiet dance of temperature and pressure, where warmth rises with anticipation, then gives way to cooler realms that invite water to gather. These droplets coalesce, eventually forming the familiar shapes we recognize as clouds, soft and dynamic, constantly evolving while suspended in the air. The rhythm of convection holds these elements together, dictating how clouds flourish. Within this gentle cycle, clouds become visible markers of atmospheric conditions, evolving continuously in response to the warmth below. The interplay of heat and moisture fosters an environment rich with potential, leading to a constant evolution of clouds above. Every shift in temperature is a note in nature's symphony, inviting more moisture to gather or disperse. As the air flows and the clouds shift, there is a calmness to the process, a reminder of the gentle workings of the world above. Kelvin Helmholtz clouds are a serene display of nature's physics, forming in the atmosphere, where layers of air interact with gentle complexity. These clouds emerge in situations where two different layers of air exist, each with its own speed and direction. When the faster-moving air glides over the slower air, a subtle instability arises. This interaction creates shear, a graceful shift in the movement of air that results in an interesting phenomenon. As the faster air flows above, it lifts the slower air beneath it. This lifting causes the slower moving layer to undulate, forming soft, wave-like patterns. These patterns ripple across the sky, resembling delicate, flowing crests of a tranquil sea. The movement is cyclical, allowing the clouds to maintain their shape for extended periods, gently shifting and adapting as air currents continue their dance. In a calm afternoon sky, they may appear as wavy streaks, a beautiful interplay of light and shadow. The clouds flutter subtly, reminding us that the atmosphere is always in motion, a gentle reminder of nature's continuous processes. The wave patterns that develop can vary, sometimes resembling smooth hills or even tight rolls, yet they remain a testament to the stability amidst change. These clouds capture a moment within the atmosphere, showcasing the balance between different air layers. Underneath the elegance of their formation lies a deeper understanding of air movement, as currents shift gracefully in a silent rhythm. The Kelvin-Helmholtz clouds weave a narrative of atmospheric dynamics, inviting the observer to notice the gentle interactions occurring far above. Each wave invites a sense of calm, a soothing presence that drifts quietly, ready to be part of the larger story of the sky. Within the delicate world of clouds, the formation of droplet sizes plays an essential role in their existence. The smallest cloud droplets, measuring about 0.01 micrometers in diameter, encapsulate a fascinating aspect of atmospheric science. These tiny droplets, so minuscule that they elude the grasp of our senses, exist in a space where the air is thick with moisture and potential. Due to their tiny size, these droplets are influenced heavily by the air around them. The atmosphere, filled with gentle currents and varying pressures, cradles these diminutive spheres. It is in this dynamic environment that they float, suspended, often too light to succumb to gravity. As a result, they may drift among larger droplets without ever reaching the stage where they could fall to the ground as rain or snow. Instead, this miniature size allows them to evaporate easily when conditions shift. Changes in temperature or humidity can guide them back into vapor, the cycle of water continuing endlessly. While they play their part in the formation of clouds, they do not serve as precipitation. They hover, light as air, waiting in the delicate balance of atmospheric conditions, where they may slowly cluster with other droplets or remain solo. When surrounding conditions allow for growth, these small droplets can collide with others, gradually coalescing into larger formations. This cooperative dance among droplets is vital, as it paves the way for the eventual creation of rain. The journey of these tiny droplets emphasizes the intricate and ever-changing nature of clouds, revealing a world that is constantly evolving in the sky. The minimum size of a cloud droplet reminds us that even the smallest entities have their own roles to play, contributing quietly to the magnificent tapestry of the atmosphere. Observing these minute details allows for a deeper understanding of the clouds above, gently encouraging thoughts to drift like those tiny droplets, floating softly in a serene expanse of possibility. In the vastness of the atmosphere, clouds play a quiet yet significant role in the interaction with sunlight. When sunlight reaches them, a beautiful dance begins as the clouds reflect and scatter this radiant energy. This interaction is known as the albedo effect, and it serves as a natural regulator of Earth's temperature. As light strikes the intricate structures of clouds, some of it is bounced back into the openness of space. This reflecting mechanism occurs continually, a gentle ebb and flow of energy, helping to maintain a balance in the atmosphere. The amount of sunlight reflected by clouds can vary depending on their thickness, density, and composition. Thicker clouds tend to reflect more light, while thinner ones allow some of the sun's warmth to penetrate deeper before dispersing. This scattering of light also creates a soft illumination in the sky, often rendering beautiful shades of white, gray, and even vibrant hues at twilight. These colors arise from the way different wavelengths of light interact with the water droplets and ice crystals within the clouds. The magnificent transformations of the clouds, painted by sunlight, create soothing vistas that drift lazily across the sky. The impact of clouds on Earth's temperature is subtle yet profound. By reflecting some solar energy, they help keep our planet from becoming overly warm. In this way, clouds nurture a gentle equilibrium, ensuring that the balance of warmth and coolness persists over time. As they float seamlessly, interacting with the light, clouds remind us of the delicate relationships in nature. This calming cycle of reflection and scattering underscores the interconnectedness of all elements in the environment, inviting thoughts to settle softly, just like the clouds keeping watch in the night sky. Cloud systems are not static entities, but are subject to change, influenced by various climate conditions over extended periods. These shifts can affect how long clouds linger in the sky, or how easily they may break apart. As temperatures gradually change, the dynamics of moisture, airflow, and temperature all interact subtly, guiding the life cycles of these atmospheric formations. Certain types of clouds, like the fluffy cumulus, may transform in their behavior as climate patterns evolve. In warmer conditions, these clouds might find it easier to dissipate, lifted away by rising warm air. This gentle variance creates an ever-changing canvas above, as some skies may become clearer, while others might see the emergence of more persistent cloud layers, almost like a blanket stretched across the blue. Over thousands of years, the experience of clouds reflects not only today's weather, but also the history of the atmosphere itself. Their formations and dispersions serve as a delicate reminder of how the climate can shape patterns far beyond our immediate observation. When weather becomes warmer or wetter, clouds may hang for longer durations, making the sky feel cozy and enveloping. The ebb and flow of these systems creates an interplay of light and shadow that can be soothing to witness. Observing clouds transform over days or in mere moments can invoke a sense of calm, a gentle reminder of the natural rhythms of our world. Each change is a thread woven into the tapestry of the atmosphere, continuing to drift and shift, inviting quiet reflection and restful contemplation. Volcanic eruptions hold a powerful influence over the atmosphere, particularly when considering events of significant magnitude, such as supervolcano eruptions. When these mighty forces of nature awaken, they release vast quantities of aerosols and gases into the stratosphere. These fine particles, once suspended in the upper layers of the atmosphere, can linger for several years, creating a veil of influence that extends far beyond the volcano itself. As they drift, these aerosols effectively scatter and reflect solar radiation. This process leads to a temporary cooling of the Earth's surface as less sunlight reaches the ground. The cooling effect can ripple through the climate system, fostering changes that reach even the formation of clouds. The altered temperatures and changes in atmospheric composition influence cloud dynamics, shifting the delicate balance of moisture in the air. In these cooler conditions, certain types of clouds may behave differently. The alterations in atmospheric energy can lead to increased cloud formation in some regions. Other areas might experience clouds dissipating more quickly, resulting in clear skies. This interplay forms complex patterns across the globe. weaving a tapestry of variable weather that can persist over months and years as the atmosphere responds to these volcanic inputs. Each eruption continues to shape the climate, creating a ripple effect that extends outward, reminding us of the interconnectedness of our planet's systems. The dance of particles and clouds above creates an ever-changing sky, a slow and gentle transformation that unfolds over time, ushering in new atmospheres and subtle variations that beckon to be observed. Within the realm of clouds, an intriguing phenomenon occurs known as supercooling. This fascinating state allows water to exist in liquid form even when temperatures dip below freezing. In the chilly expanse of a cloud, the delicate balance of conditions enables water droplets to remain unfrozen, creating a unique environment suspended in time. Tiny particles within the cloud, like dust or ice crystals, often serve as nuclei around which water can condense. However, when conditions are just right, the surrounding temperatures can dip low enough to encourage supercooled water droplets to exist in a liquid state, despite being under 0 degrees Celsius. This situation can persist for a considerable duration, allowing these droplets to float quietly amid the cloud. These supercooled droplets contribute to the dynamic nature of clouds. They can merge with one another, growing larger as they drift and collide. Eventually, if the conditions change, they can freeze quickly to form ice crystals. At times, this transformation might lead to the gentle snowfall on the ground as the supercooled state gives way to solid ice. The ability of water to remain liquid in these cool, elevated spaces illustrates the delicate balance of physical states in the atmosphere. Layers of supercooled droplets create a serene inner life within the cloud, where transformation is always possible, inviting a sense of calm and quiet wonder. Each cloud becomes a soft nest of spectral droplets, waiting for the right moment to awaken and shift, continuing their ethereal journey across the sky. The continuous dance of evaporation and condensation plays a vital role in the life of clouds. This cycle begins with the warmth of the sun, which gently heats bodies of water, causing them to transform into vapor. As this vapor rises, it cools and interacts with the surrounding air, leading to the formation of tiny water droplets. These droplets gather together, forming clouds that drift across the sky. Gravity holds these droplets close, influencing their behavior. As they accumulate and grow, the droplets can merge and combine, increasing in size. When the droplets become heavy enough, they may begin to fall, cascading back to the earth in the form of rain or snow. This return to the surface contributes to the ongoing cycle, allowing water to nourish the ground, feeding rivers and lakes, only to be evaporated once more. Throughout the day and into the night, this process unfolds with a graceful regularity. The constant interplay between warmth and coolness orchestrates the birth of clouds as they form, dissipate, and transform, mirroring the ever-shifting nature of the atmosphere. Each moment offers a new spectacle, a reminder of how dynamic and fluid the world above can be. Even when clouds fade away, the water vapor remains, ready to rise again and start anew. This gentle cycle, powered by sunlight and influenced by the pull of gravity, ensures that clouds will always return, perpetuating the soft, ever-changing tapestry of the sky. Each cloud, an embodiment of this process, silently carries the movement of water within the atmosphere, inviting contemplation and calm. Marine stratocumulus decks appear like soft, sprawling blankets across the ocean surface. These clouds develop over cooler waters, where the temperature difference between the sea and the atmosphere creates a stable layer of air. This stability helps maintain their presence, allowing them to linger for days or releases moisture into the air, feeding this layer of clouds with a steady supply of water vapor. This gentle process forms a rich connection between the ocean and the sky. The moisture rises, mixes with the cooler air above, and contributes to cloud formation, creating a thin layer of stratocumulus that can stretch for miles. As these clouds hover above the ocean, they also reflect and scatter sunlight, altering the appearance of the sea beneath them. Their soft shapes shift slowly, moving with the gentle currents of the wind. Occasionally, they may dissipate slightly, only to regroup and reform, continuing their quiet existence, held aloft by the balance of temperature and moisture. The presence of marine stratocumulus can influence the atmosphere around them, subtly regulating temperatures and creating a unique microclimate over the ocean surface. Each moment spent observing their gentle structure reveals the tranquility of a dynamic system, working gracefully and continuously. The clouds drift softly, embodying a fleeting yet persistent beauty, inviting a sense of calm as they paint the horizon. Clouds, with their ever-changing forms, carry a delicate nature that prevents them from lasting forever. They arise from water vapor that condenses into tiny droplets or ice crystals, gathering together to create visible patches in the sky. Yet, though they may appear stable and enduring, clouds exist in a constant state of transformation. As conditions shift, the tiny droplets within clouds can change. When warmth returns, the droplets may begin to evaporate, slowly returning back to vapor. In this gentle process, the cloud gradually thins, often losing its distinct shape and structure. Changes in air temperature or pressure can also influence their lifespan, pushing these atmospheric formations to dissipate and disperse. The dance of the atmosphere does not favor permanence, and clouds can experience cycles of growth and decay. Some may evolve into larger formations, while others may fade into thin wisps, almost like whispers in the sky. Dynamic currents of air draw them upward, and at times, clouds may be lifted high before they dissolve, allowing their particles to meander through the atmosphere until they find a new form. Even when they vanish, the essence of water never truly disappears. It transforms and enters new cycles of nature. Clouds exemplify the gentle impermanence of our atmosphere, reminding us of the beauty and change that is inherent within the natural world. In the quiet embrace of the night, their presence lingers softly in memory, suspended between existence and absence, inviting a peaceful reflection on the transient wonders of the sky. The lifespan of a cloud can reflect a wide range of times, often dictated by the surrounding atmospheric conditions. Some clouds, like cumulus varieties, are known for their fleeting presence. They may form on a warm day, growing quickly in a puffy cotton-like shape. They can vanish just as rapidly as they appeared, sometimes lasting only minutes. This quick transformation is influenced by instability in the air, where rising warm currents promote their brief existence, followed by a gentle descent into nothingness. In contrast, stratiform clouds display an entirely different nature. These extensive layers often blanket the sky for longer durations, with their soft, uniform appearance stretching across vast areas. Their formation and persistence arise from stable atmospheric conditions where moisture abounds, allowing these clouds to linger serenely without the abrupt changes seen in their cumulus cousins. Layers of air support their steady persistence, with gentle moisture dynamics nurturing their slow evolution over days. As time passes, both types of clouds undergo subtle changes. Cumulus clouds may build, swell, and fall apart, while stratiform clouds gently transform into various shades and densities, softened by the shifting light. The interplay of temperature, moisture, and movement ensures that each cloud reflects a unique moment in the atmosphere, captured in a transient dance. The life of a cloud, whether brief or enduring, unfolds in an ever-changing sky, offering a quiet spectacle of nature's rhythm, inviting thoughts to drift along with the shapes above. Within the serene structure of clouds, a gradual process unfolds as ice crystals and water droplets drift and collide in the ever-dynamic atmosphere. These interactions are gentle, yet significant. When ice crystals, often forming in the colder upper regions, bump against tiny water droplets, they exchange energy and, in turn, electrical charges. This sifting and settling create areas of positive and negative charge. An internal electrical potential begins to build quietly within the cloud. As these collisions continue, charge separation grows slowly but steadily. Clouds become vast systems, each capable of harnessing this energy in layers and pockets, invisible to the naked eye, but integral to the cloud's behavior. The delicate balance of temperature and moisture contributes to this intricate dance, with droplets merging and breaking apart, while ice crystals accumulate, enhancing the charge separation within their midst. Time passes, and this gradual accumulation reaches a point of tension. The strength of the electrical potential within the cloud can intensify, ultimately leading to a release in the form of lightning. When conditions align perfectly, this stored energy flows between the differently charged areas, creating the brilliant display that briefly illuminates the sky. The process embodies a powerful interplay of natural forces, continuously shaping the clouds and the atmosphere itself. As these atmospheric mechanisms unfold, each cloud tells a story of energy, persistence, and the quiet complexities of weather, revealing the subtle yet profound forces at play, waiting to be noticed above. Beneath the surface of the Earth lies a dynamic interplay known as tectonic activity. The crust, a thin layer enveloping the planet, is divided into large sections called tectonic plates. These plates shift and move, albeit at an imperceptibly slow pace, drifting apart or colliding with one another over millions of years. This movement is like a gentle rhythm beneath our feet, a continuous process that reshapes the very fabric of the Earth itself. As these plates interact, they alter the landscape in profound ways. When they drift apart, new ocean floors can emerge from underwater volcanic activity, quietly adding to the oceanic expanses that cradle continents. As some plates converge, immense pressure builds up. This pressure is eventually released, often causing the land to buckle and rise, forming new mountain ranges that stand strong and silent as time flows around them. These geological processes are responsible for transforming coastlines, carving out valleys, and creating environments that will later support diverse ecosystems. The coastlines evolve slowly, their edges sculpted by the ceaseless embrace of waves meeting land, while mountains, born through the collision of tectonic plates, rise majestically, telling the story of the Earth's enduring strength. While these shifts occur at a pace almost invisible to human observation, they remind us of the Earth's ever-changing nature, a quiet but powerful force shaping the world around us through the passage of time. Each gentle movement is part of a larger narrative, an ongoing tale of transformation, stability, and the captivating dance of the Earth's elements, flowing quietly into the vastness of existence. In the vast expanse of the sky, clouds form and drift, their presence influenced by the atmospheric conditions around them. Layered clouds, such as stratus, have a gentle, even appearance, often stretching across the horizon like a soft blanket. When the atmosphere holds a large mass of moist air, and the temperature within that air mass remains relatively uniform, These clouds can linger comfortably for days. This sustained moisture provides the fabric for these clouds to exist without disruption. As moisture accumulates and the air remains stable, these stratus clouds settle into place. The uniformity in temperature creates a calm environment where significant vertical movement is stifled. The clouds form a continuous, low-lying layer, casting a soft, diffused light on the landscape below. They drift lazily, reflecting subtle changes in the light as the sun moves across the sky, creating gentle variations in hue and brightness. The persistence of these cloud layers can transform the atmosphere subtly, offering a soothing gray that envelops the surroundings, providing a sense of shelter. Over time, they gently absorb and release moisture back into the air, contributing to the water cycle in a quiet and unnoticed manner. The stable nature of these clouds offers a moment of tranquility, reminding us of the calm that can exist in the world around us. As they float on, still and serene, a sense of peace lingers in the air, inviting us to embrace the quiet beauty of this delicate balance in the sky, effortlessly lasting in their presence and ready to continue unfolding their story. In the vast realm of the Earth's atmosphere, clouds can take on many forms, and some can exist in remarkably frigid conditions. When temperatures drop below -40 degrees Celsius, clouds may transform into delicate structures composed of ice crystals or supercooled water droplets. In these extremes, a fascinating interplay of physics occurs, creating beautiful, shimmering formations that float quietly in the sky. Supercooled water is a unique phenomenon. It remains liquid even in temperatures well below freezing, held in this delicate state due to a lack of nuclei around which ice can form. However, when the temperature finally dips below a certain threshold, even the most resilient of these supercooled droplets will freeze, transforming into solid ice crystals. The environment around them remains still and serene, fostering a peaceful coexistence of ice and water in the heavens. These icy clouds create an ethereal ambiance, often appearing wispy or layered across the sky. The light filtering through them can cast a soft glow, illuminating the surrounding atmosphere in gentle blues and whites. These clouds, suspended high above, patiently float on the currents of the air, maintaining their fragile structure as they drift across vast distances. In this realm of cold, the characteristics of the clouds change slowly, adapting to their environment while remaining part of a complex and interconnected system. The tranquil nature of these clouds encapsulates the essence of balance in the atmosphere, guiding us to appreciate their quiet resilience and beauty. The icy formations continue to linger, seamlessly woven into the fabric of the sky, inviting us to explore the wonders they hold, ready for the next whisper of activity in the stillness above. Cloud droplets and ice crystals form through a gradual and delicate process that unfolds in the atmosphere. Starting from microscopic sizes, droplets can measure as small as 0.01 millimeters. These tiny particles often act as the building blocks of clouds, existing in a world that feels enchanting yet serene. As they float through the air, they quietly collide with one another, a gentle dance that allows them to grow larger over time. This growth is a slow and continuous process, driven by condensation. Water vapor in the air gathers around these miniature droplets, gradually adding to their mass. Through additional collisions with adjacent droplets, they begin to coalesce, forming larger droplets. The size of these droplets can shift between the realms of the invisible and the tangible, expanding into visible raindrops or hailstones that can measure several millimeters across. In the ever-changing sky, the growth of these water particles is influenced by various atmospheric conditions. The temperature, humidity, airflow all play key roles. Hailing from such an intricate process, the droplets embody a gentle balance, floating harmoniously within their cloud formations. It is in their nurturing cocoon of moisture that they come to existence, nurtured by the surrounding air as they prepare to fall back to the earth. This gentle process serves as a reminder of the harmony present in nature, where each tiny droplet contributes to larger weather patterns and provides nourishment to the world below. Together, these clouds drift softly, maintaining their serene presence, while the quiet evolution of the droplets and crystals continues in a slow, rhythmic cycle, awaiting the moment when they may return to the earth in soft, soothing rain or playful ice. Within the delicate realm of a cloud, air parcels are caught in a constant dance, influenced by gentle vertical air currents that ebb and flow. As these parcels rise, they undergo expansion, causing their temperature to decrease. This process, known as adiabatic cooling, occurs without any exchange of heat with the surrounding environment. Instead, the internal energy within the air parcels shifts, leading to a cooler sensation that plays a pivotal role in the cloud's presence. Conversely, when these parcels descend, they compress, and this compression warms the air, reflecting an increase in temperature. Through these ongoing changes, the cloud experiences dynamic transformations that affect its overall structure and development. This cycle of expansion and compression contributes to cloud buoyancy, supporting its formation and evolution in a slow, rhythmic pattern. Humidity within the cloud is intricately tied to these temperature changes. As air cools, it can hold less moisture, leading to potential condensation. This might result in the formation of tiny water droplets or ice crystals, expanding the cloud's makeup and impacting its density. These processes are subtle yet essential, creating a network of moisture that varies continuously. The energy dynamics within a cloud underline its ephemeral nature. Each current shifts the air, fostering a vibrant environment where new droplets can form, grow, and sometimes drift apart. The intricate balance of temperature and humidity allows the cloud to maintain its ever-changing form, reflecting a natural state of equilibrium in the atmosphere. As the cloud gracefully evolves with the currents, it holds the promise of rain or further transformation, ready to engage in its next gentle cycle. Throughout the Earth's systems, carbon moves in a gentle, continuous cycle, weaving through the atmosphere, oceans, land, and the myriad forms of life that inhabit our planet. This intricate process unfolds over expansive timescales, allowing carbon to shift and transform in ways that subtly influence global climate across millennia. In the atmosphere, carbon exists in various forms, most notably as carbon dioxide, where it plays a role in regulating temperatures by trapping heat and contributing to the overall balance of energy received from the sun. As this gas drifts, it can dissolve into oceans, where it interacts with water molecules to form carbonic acid. This transformation creates a dynamic relationship with aquatic life. Marine organisms use carbon to form shells and skeletons, integrating this element into their structures. When these organisms die, they settle to the ocean floor, and over time, they contribute to the sediment that harbors ancient carbon, effectively storing it away for long periods. Meanwhile, on land, plants absorb carbon dioxide during photosynthesis, utilizing it to grow and thrive. Through this process, they also release oxygen, a critical exchange that supports life. As plants die and decompose, the carbon stored within them returns to the soil, enriching it and supporting new growth in an ongoing nourishing cycle. There are places where carbon can be locked away in rocks or fossil fuels for millions of years, creating a reservoir of carbon that slowly interacts with geological processes. Each shift within the carbon cycle is measured in eons, reflecting the profound interconnections between the atmosphere, the oceans, the land, and living organisms. These slow exchanges, although imperceptible in human terms, create an enduring impact on Earth's climate. Through gentle movement and transformation, carbon links all aspects of the planet, continuously shaping the environment and maintaining a delicate balance over vast stretches of time, ready to drift once more into its next phase. Shelf clouds quietly form at the leading edge of a thunderstorm's outflow, taking on a distinctive wedge shape that hangs just above the ground. These clouds are usually dense and dark, serving as striking visual markers of the approaching storm. As cool air pushes out from the thunderstorm, it can meet warmer, moist air, causing the formation of these low-hanging structures. The presence of shelf clouds often signifies a transition in the atmosphere. Their ominous appearance is a signal that gusty winds are on the horizon, indicating the movement of a thunderstorm system. This dense mass of water vapor and ice crystals can stretch across the sky, casting shadows on the landscape beneath. Observers may notice the atmospheric changes surrounding these clouds, as the air may grow still and quiet just before the winds begin to pick up. As the storm approaches, droplets coalesce within the shelf cloud, ready to fall. The clouds become thicker as they gather moisture, and soon, the gentle sound of raindrops begins to patter as they reach the earth. The interplay of winds and moisture creates a dynamic scene, one rich with energy shifting in the atmosphere. As the storm reinforces its presence, shelf clouds continue to evolve, moving with the changing conditions. They are transitional structures, bringing a blend of tension and anticipation as nature prepares for the water to cascade down. With every passing moment, these clouds remind us of the fluidity of weather, as they both announce the rain and form part of a continuous cycle of evaporation and precipitation. As they roll away, the calm that follows can feel almost palpable, leaving a refreshed landscape in their wake. Air masses in the atmosphere are constantly shifting and changing due to variations in atmospheric pressure. These shifts are often significant during weather fronts, where two different air masses meet. When warm, moist air collides with cool, dense air, the interplay of these differing temperatures can create a delicate balance that influences cloud formation. As atmospheric pressure changes, air begins to either rise or fall, affecting how the surrounding air behaves. When warm air rises, it expands and cools, allowing moisture to condense. This condensation brings clouds to life, creating a canvas of shapes and textures that float through the sky. In contrast, when cooler air pushes downward, there is a chance for clouds to dissipate. The moisture may evaporate back into the atmosphere, leading to clearer skies. The intensity of clouds can also fluctuate as air masses continue to move. In times of low pressure, conditions often become ripe for clouds to thicken and deepen. As more air rises, the clouds can grow taller, inviting storms to form. Conversely, when high pressure prevails, the atmosphere stabilizes, allowing for lighter clouds or even clear blue expanses. This continuous cycle of expansion and contraction is a fundamental aspect of the atmosphere, shaping the weather patterns we observe. The delicate dance of air currents plays a vital role in determining how clouds will develop over time, whether they will billow and expand into dense formations or gently fade away. In their own way, these processes weave a tapestry of weather that flows quietly through the atmosphere, echoing the intricate balance of elements that exists all around us. Clouds are composed of countless tiny water droplets, each one delicate and light. The size of these droplets is tightly controlled by the physics of gravity and the forces acting upon them. Each droplet forms when water vapor in the atmosphere cools and condenses around tiny particles, becoming suspended in the air. As droplets grow, they encounter gravity's gentle pull. This force is always at work, influencing their ability to float freely. The larger a droplet becomes, the more weight it gains. There comes a threshold where its size exceeds the delicate balance needed to stay aloft. Beyond this point, the droplet will fall, unable to defy gravity's grasp. This means that while cloud droplets can vary in size, there exists a limit to how large they can become while remaining part of the cloud. Interestingly, this balance affects the overall appearance of clouds. When droplets are small, they scatter sunlight, giving clouds their soft white appearance. Larger droplets, which hover at the edge of falling, create a different visual effect. They may combine with others, coalescing to form a more substantial droplet, yet this can lead to a quick descent from the cloud as they grow heavier. Through this constant dance of formation and falling, cloud systems adjust and evolve. The atmosphere holds their suspended beauty, while gravity subtly governs the tiny droplets that make up these formations. This quiet interplay continues, reminding us of the serene cycle within the vastness of the sky, where even the smallest droplets have a role in the symphony of nature. Above the bustling forms of cumulus and cumulonimbus clouds, a fascinating phenomenon can emerge, known as pileus clouds. These smooth, elongated formations create an almost gentle cap, resting lightly above the more dynamic clouds below. They are not permanent structures, but rather transient features that appear in response to the strong updrafts found in rapidly developing clouds. As moist air rises within a cumulus cloud, it pushes upward, reaching the cooler layers of the atmosphere. In this process, the air cools and condenses, leading to the formation of the soft, cap-like pilus. This condensation occurs because the moist air encounters a temperature drop, transitioning from vapor to delicate water droplets, which cluster together. The result is a layer that glows softly, often highlighted against the backdrop of the more tumultuous clouds beneath it. The presence of pilus clouds hints at the powerful forces at play in the sky. They serve as a visual marker of strong upward motion, showcasing the interactions of air currents and moisture in a constantly shifting atmosphere. While they may appear serene, they are closely tied to the energetic processes in the clouds below. As the updrafts continue, the pilus may change in form, sometimes expanding or contracting, but always remaining a testament to the balance of forces at work. These cap-like clouds drift softly, cradled by the wind, embodying the calmness that often belies the gathering conditions beneath. Observing them can evoke a sense of wonder at the intricate and gentle workings of the atmosphere. In this quiet realm, the interplay of moisture and airflow creates a captivating dance, inviting a peaceful contemplation of the skies. Over the course of tens of thousands of years, the Earth experiences cycles that bring about ice ages, periods where massive sheets of ice enveloped vast regions of the land. These ice sheets, formed from the accumulation of snow, compacted over millennia, slowly grow larger as the climate cools. With each passing year, the weight of the ice presses down, causing changes in the underlying landscape. The sheer size of the glaciers can reshape valleys and create new landforms as they carve through the rock and soil, leaving behind a tapestry of scars. As the ice advances, oceans and seas react in response. When ice sheets grow, more water becomes trapped in the form of ice, causing sea levels to drop. This gradual decline can create new coastlines and alter ecosystems. As temperatures begin to shift and warm, the ice starts to melt, releasing the stored water back into the oceans. The seas rise, submerging land that had previously been dry and transforming the world once again. The retreat of ice sheets is often a slow process, allowing for the emergence of new habitats. Plant and animal life adapts to these changing conditions, gradually colonizing areas once covered by ice. This cycle of advance and retreat happens over many generations, continually shaping the planet in profound ways. The shifting ice and changing sea levels are reminders of the Earth's dynamic climate system, where the slow and steady rhythms of nature play out over immense stretches of time. This delicate balance of cooling and warming sparks an ongoing conversation within the planet's climate, creating a tapestry of environmental change that is ever-flowing, inviting contemplation of nature's resilience and beauty. As the cycles continue, they weave the fabric of our world, altering landscapes and creating patterns that echo through the ages, reminding us of the tranquil yet powerful forces at play in the Earth's systems. Amid the vast sky, clouds drift gently, carrying within them significant amounts of latent heat energy. This energy is stored when water vapor, invisible and formless, transforms into tiny droplets of liquid water or ice crystals. As the vapor condenses, a delicate process occurs. The release of this energy warms the surrounding air, creating a subtle shift in temperature. Each droplet formed plays its part in a larger symphony of climate and weather. These tiny particles, suspended in the atmosphere, do not simply float aimlessly. They interact with one another, with the air around them, and with the sunlight filtering through. The heat released contributes to atmospheric circulation, driving gentle winds that weave through the sky. This movement of air influences weather patterns, guiding storms, rain, and sunshine. Variations in temperature, driven by the energy exchange occurring within clouds, help form the soft transitions of warm and cool air that play out over days and seasons. In many regions, clouds ensure that energy is distributed evenly across the planet. They act as an important part of the local energy budget, where the exchange between heat and moisture persists, influencing what comes next. A delicate balance is maintained as clouds help to regulate temperature and create humidity, which in turn shapes the landscape below. The slow, persistent release of latent heat assists in the constant dance of the atmosphere, guiding fluctuations in weather and climate. The remarkable stability of these processes leads to an ever-changing yet continuously reliable rhythm in the sky, nurturing ecosystems throughout every transition. As clouds shift and transform, they keep the energy flowing, preserving the intricate connections within the atmosphere, inviting both wonder and tranquility as they drift through the endless expanse. Beneath the gentle embrace of clouds, the Earth experiences a soft, tranquil shading that can lower temperatures and create a peaceful atmosphere. This temporary shielding from solar radiation results from the cloud's interaction with light. Each type of cloud, from the delicate cirrus to the thick and fluffy cumulus, has a different ability to reflect, scatter, and absorb sunlight, creating a variable blanket of coolness below. The thickness of a cloud plays an essential role in this process. Thicker clouds, laden with water droplets or ice crystals, scatter sunlight more effectively, leading to greater reductions in temperature on the ground. The soft, diffused light filters through, creating a serene ambiance as it travels to the surface. The dance of light and shade can feel almost rhythmic as clouds drift gracefully across the sky, altering the sunlight's intensity like a gentle wave rolling through a quiet sea. When clouds form, they not only block sunlight, but also influence the surrounding air. The cooler temperatures that develop beneath can create a refreshing contrast, especially on warm days. This interaction helps maintain the delicate equilibrium of local climates, enhancing the soothing presence of shade and coolness. The clouds, with each unique formation and density, ebb and flow with the atmosphere, orchestrating a tender balance between light and shade. Their serene journey through the sky fosters an ever-changing tapestry of weather that continues to soothe, gently nudging temperatures lower and providing moments of respite. The quiet magnitude of this process lingers, inviting us to observe how clouds softly shape the world beneath them. Cumulonimbus clouds rise high into the atmosphere, reaching up into the stratosphere with a majestic presence. Their towering structures often resemble immense pillars, growing from the warm surface below and climbing toward the cooler heights above. These clouds can form in a variety of conditions, thriving in warm, moist air. As they build upwards, they gather more water vapor and energy, creating an intricate internal structure. Once established, some cumulonimbus clouds can persist for several hours, evolving through stages of development. They may begin as fluffy, cotton-like shapes before transforming into dark, dense formations. As they grow, they can influence the weather dramatically, leading to thunderstorms that bring not just rain, but also the possibility of hail and lightning. The electrical activity within these clouds is a fascinating aspect of their nature, as charged particles move and collide, creating flashes of light and rumbling sounds that can echo across the sky. While they are often a source of tumultuous weather, the sheer scale of cumulonimbus clouds is captivating. Their presence signifies a dynamic atmosphere at work, exhibiting the power and energy that circulates around us. As they drift and develop, they may interact with other elements in the sky, sometimes merging with other clouds or drawing in air from the surrounding environment. Even as they produce storms, the formation of cumulonimbus clouds contributes to the constant movement of air and moisture throughout the atmosphere. The intricate dance of these clouds reflects the larger rhythms of weather systems, leaving a trace of their activity that lingers in the air long after they dissipate. The gentle ebb and flow of their life cycle continues, quietly influencing the atmosphere, ready to embrace the changes that lie ahead. The mass of a cloud can indeed be enormous, particularly for a cumulus cloud, which contains hundreds of thousands of tons of water. This weight is not concentrated in a small space, but is instead distributed across a vast volume of air. The arrangement of water droplets within the cloud is delicate. Each droplet is suspended in the atmosphere, buoyed by rising air currents that support it. As water vapor rises, it begins to cool, transitioning from a gas to liquid droplets. This process occurs gradually and is influenced by the temperature and pressure surrounding the droplets. Evaporation also plays a role, allowing the cloud to change its mass continually. Droplets can evaporate back into vapor when conditions shift, causing the cloud to shrink and lighten. These fluctuations happen slowly, leading to a dynamic equilibrium where water is constantly condensing and evaporating. The immense weight of the cloud serves as a reminder of the interconnectedness of the water cycle. Each droplet is a small part of a larger system, moving through the environment in a slow, rhythmic dance. Clouds can float high above, yet carry this incredible mass with grace, gently shifting shape and form as they drift across the sky. As time passes, these clouds may release their load, resulting in rain that nourishes the earth below, returning the water to the ground. Even in moments of stillness, the potential energy within a cloud remains. Although they can appear soft and gentle, they possess a remarkable complexity, revealing layers of interaction between droplets and the air around them. The quiet presence of clouds above is a continuous cycle, turning and changing like the passage of night, ready to convey the soothing rhythms of nature above and beyond. Ocean currents, those broad rivers of water that flow slowly across the surface of the sea, undergo changes over many centuries. These currents, vast and deep, are influenced by subtle shifts in salinity and temperature. As water warms or cools, it gains or loses density, affecting its movement in the ocean. When surface waters are heated, they rise, creating areas of lower pressure, while cooler waters sink, creating a cycle of flow that can persist over great distances. Salinity, or the concentration of salt in water, also plays a crucial role. When fresh water from melting ice or heavy rainfall enters the ocean, it alters the salinity, prompting currents to adjust their path. These changes are often so gradual that they become almost imperceptible, weaving a complex pattern over vast stretches of time. As currents shift, they carry heat around the globe. Warm water from the equator flows toward the poles, imparting warmth to cooler regions, while cold water makes its way back toward the equator, creating a constant circulatory system. This slow and steady redistribution of heat plays a vital role in regulating the planet's climate, influencing weather patterns and ecosystems along coastlines. In the depths of the ocean, these currents move with an unhurried grace, unseen, yet ever present. Their gentle movements contribute to the dynamic balance of the earth, as warm and cold waters mix and mingle, forming a fluid tapestry that spans the vast oceans. Over centuries, these currents adjust and redefine pathways, reflecting the continuous dialogue of nature, always in delicate motion, waiting to unfold further in the embrace of time. Clouds drift gracefully across the expansive sky, composed mainly of tiny water droplets or ice crystals. These delicate formations vary in density, which in turn affects their appearance and behavior. Thin cirrus clouds, often found high in the atmosphere, have a density of less than 0.1 grams per cubic meter. They appear wispy and ethereal, allowing sunlight to filter through in soft, muted tones. Their light, airy nature gives them a gentle presence against the blue backdrop of the sky. In contrast, the robust cumulonimbus clouds, which can tower majestically, may exceed a density of 1 gram per cubic meter. These clouds are dense and heavy, filled with moisture. Their considerable weight contributes to the potential for rain, thunderstorms, and other forms of precipitation. As they build, they can block out sunlight more effectively, casting shadows on the earth below. The interplay of these various clouds creates a constantly shifting tapestry above, with light and darkness mingling in a tranquil dance. With every gentle breeze, clouds move and change, their density influencing the weather patterns that unfold beneath them. The delicate balance of water and ice, along with the varying density, plays a crucial role in determining how much light is absorbed or reflected, impacting the warmth felt below. This ongoing transformation contributes to the serenity of the sky as clouds continuously adapt and evolve. Finding solace in their presence, one can watch as they drift, merging into shapes and forms that offer a soft spectacle, carrying within them the promise of rain and the coolness of shade. The atmosphere remains charged with potential, and in this quiet expanse, the clouds await their next move, ready to reveal the wonders of nature's rhythms. Within the wispy layers of clouds, water vapor plays a vital role, moving seamlessly between liquid and gas. This continuous state change involves the absorption and release of latent heat, a kind of hidden energy that is not immediately visible. When water vapor condenses into tiny droplets, it releases warmth into the surrounding air, a gentle embrace that can affect the temperature of the atmosphere. Conversely, when these droplets evaporate back into vapor, they absorb heat, creating a coolness that permeates the air. This delicate exchange of energy encourages movement within the atmosphere. Warm air rises, carrying moisture upward, while cooler air flows in to replace it, a soothing cycle of birth and transformation. The clouds, constantly evolving, can linger in the sky for days, engaging in this process of absorbing and releasing energy as they grow darker and fuller or disperse into thin, feathery wisps. This continuous cycle contributes significantly to the broader patterns of atmospheric circulation, assisting in the distribution of heat around the globe. As clouds form and dissipate with the rhythm of nature, they dance through time, their latent heat interwoven with the atmosphere's fabric. Warmth and coolness mingle, creating zones of stability and turbulence alike. In this calm exchange, clouds paint a serene portrait in the sky, a quiet testament to the intricate workings of the world above. The water vapor, ever patient, continues its journey, engaging in a cycle as old as the earth itself, steadily influencing the climate with its gentle presence. The atmosphere breathes and shifts, waiting in soft anticipation for what comes next. Within the gentle embrace of a cloud, the water content fluctuates, measured as either liquid water path or ice water path, depending on the conditions present. These variations can be quite significant. When the cloud holds a larger amount of water, it appears denser and more robust, often reflecting sunlight in a way that creates a bright white appearance against the sky. Conversely, when the water content is low, the cloud can take on a more transparent quality, allowing more light to pass through, thus gradually revealing the hints of blue sky beyond. This dynamic nature of water content is influenced by the available moisture in the atmosphere. Clouds often form in response to the rising air, which lifts and cools the moisture present, allowing it to condense into droplets or freeze into ice crystals. As these processes unfold, the cloud adjusts its water content slowly, responding to the ever-changing environment around it. Sometimes they may expand and swell with moisture, holding the promise of precipitation, while at other moments they may thin out as the moisture is released back into the atmosphere. In this gentle cycle, clouds also play a role in the larger ecosystem of weather. Their ability to hold or reflect water not only affects rainfall, but also influences local temperatures and the overall dynamics of air currents. These adjustments can be gradual, as clouds weave through a tapestry of atmospheric influences, always adapting to the moisture available and the temperature of their surroundings. In this way, the life of a cloud continues, a serene balance of change, patiently awaiting the next stage of its existence. The serene presence of clouds drifts quietly across the sky, their water content ebbing and flowing, a subtle rhythm in the vastness above. Clouds are not static entities. Their interaction with sunlight adapts over time, a gentle reflection of their ever-changing nature. As clouds develop and evolve, properties such as thickness, water content, and even the size and shape of droplets all play a role in how they respond to the sunlight that bathes them. When clouds are thick and heavy, they tend to reflect a significant amount of sunlight, creating a bright, luminous appearance. This reflectivity can vary as clouds shift and change, affecting how much light is absorbed and how much is sent back into the atmosphere. With time, the composition of the atmosphere surrounding the clouds also influences these interactions. As particles and gases fluctuate, they can affect the cloud's formation and behavior. For instance, an increase increase in particulate matter can enhance the light scattering within the clouds, leading to greater reflectivity. Conversely, if the air is clearer and less contaminated, clouds may absorb more sunlight, which can lead to warmer hues as light interacts with their edges or interiors. These transitions are often slow and subtle, reflecting a deeper connection to the overall atmospheric processes. Around the same cloud, the sunlight can play different roles at different times, casting shadows and illuminating colors in a soft dance of light and dark. As clouds thicken or thin, their relationship with the sun continues to evolve, creating a ceaseless cycle of change. Each moment brings a new nuance to light as it filters through these soft formations, contributing to the ambient atmosphere that surrounds them. This tranquil exchange between clouds and sunlight flows endlessly, a soothing reminder of the serene complexity of nature above us. Fall streak holes present an intriguing sight within the expansive canvas of the sky. These formations emerge as large circular or elliptical gaps within clouds, particularly those composed of cirrocumulus or altocumulus. The processes that give rise to these peaceful openings are gentle yet fascinating. At their core, fall streak holes occur when ice crystals within clouds begin to grow. These ice crystals can develop under specific atmospheric conditions, gathering moisture around themselves until they become heavy enough to break away from the cloud layer. As these crystals fall, they create a clear space, resulting in the beautiful void of a fall streak hole. This phenomenon allows sunlight to pour through, illuminating the environment below in a soft glow, often contrasting beautifully with the nearby cloud formations. The surrounding clouds can take on a delicate appearance as they shift, revealing the stark blue sky beyond. The area within the hole can be filled with a sense of quiet and calm as the surrounding presence of clouds remains, keeping the scene serene. This subtle dance of ice crystals falling and sunlight streaming through encourages a gentle interaction between the elements. Over time, the delicate balance that creates fall streak holes can lead to even more gradual transformations. The atmosphere remains in a state of gentle motion, where new ice crystals might form and shift within their cloud space. Each moment in the sky unfolds softly, filled with possibilities. The existence of these gaps serves as a reminder of the delicate interplay between ice, cloud, and light, a soothing testament to nature's quiet beauty that carries on above us. The rhythm of solar cycles unfolds gently across the expansive skies, marked by approximately 11-year intervals known as the sunspot cycle. Within this cycle, the sun experiences fluctuations in energy output, a soft ebb and flow of radiant energy that influences its interactions with the surrounding cosmos. Sunspots, which are temporary phenomena, serve as indicators of this dynamic activity. Their presence hints at a deeper orchestration of solar magnetic activity, impacting the sun's overall brightness. As these cycles progress, subtle variations in solar energy reach Earth, caressing our atmosphere in quiet waves. Although these changes occur over relatively short periods, they are woven into a broader tapestry of solar activity. The consequences of these energy fluctuations can ripple through Earth's upper atmosphere, where delicate balances of temperature and pressure shift ever so slightly. The effects extend beyond mere temperature adjustments. They hold the potential to influence cloud formation and atmospheric chemistry. The gentle play of solar energy can perturb the very fabric of our atmosphere. Variations in solar output may interact with existing weather patterns, affecting cloud structures and the delicate equilibrium of gases that cradle our planet. These influences are often mild and complex, reflecting the intricate web of interactions that define our atmospheric conditions. Over time, a subtle dance unfolds, punctuated by the rhythms of solar cycles. These changing dynamics can cultivate environments that nurture new patterns, hinting at shifts that may emerge quietly over the years. Through it all, the balance of solar activity persists as part of a larger cosmic structure, a reminder of nature's interconnectedness and the myriad ways energy flows through the universe. Each cycle merges into the next, inviting an endless exploration of the gentle whispers of space and time, continuing to shape the world above. The world of clouds shifts in quiet rhythms, with instances of formations like thunderstorms reflecting subtle changes within the atmosphere. These cloud formations, while they can appear sudden and dramatic in the moment, are part of a slower, longer-term dance influenced by various factors. Over centuries, the frequency of thunderstorms can change gently, mirroring the delicate balance of atmospheric conditions. Warming trends that unfold gradually can alter the moisture content high above. As temperatures rise, more water evaporates, filling the air with humidity, setting the stage for complex interactions among atmospheric elements. An increase in moisture can lead to a greater occurrence of storm systems as the air becomes rich with building energy. Conversely, in cooler phases, the atmosphere might become drier, leading to fewer such events. These changes do not happen overnight. Instead, they evolve slowly, a quiet transformation observed only over lengthy periods. The balance of heat and moisture gently tilts under the influence of vast climatic patterns. Atmospheric dynamics, swirling and shifting, subtly alter how clouds gather and disperse. Over time, the landscape of weather takes on new shapes, reflecting not just immediate conditions, but the broader, slower rhythms of the Earth's climate. With each passing season, the pulse of the atmosphere continues on, adjusting, refining, and reweaving the fabric of weather. This ongoing process invites an awareness of the intricate relationships within our environment, connecting elements of warmth, moisture, and air. The sky remains a canvas, ever evolving, where each gentle shift contributes to a larger narrative that unfolds much like the clouds themselves, soft, subtle, and endlessly fascinating. In the gentle expanse of the sky, clouds drift with graceful ease, their presence shaped by the subtle influences of Earth's climate. Over the course of millennia, the altitude at which clouds typically form can experience a gradual yet profound change. This slow upward shift occurs in response to warming temperatures and evolving atmospheric circulation patterns. As the Earth warms, layers of the atmosphere also respond, with warmer air rising higher into the sky. This increased warmth affects the vertical structure of the atmosphere, altering where clouds have the best conditions to develop. The necessary combination of moisture, temperature, and rising air currents works together in perfect harmony, determining the altitude at which clouds can create their beautiful formations. The delicate dance of air and temperature leads to fine adjustments in the height of cloud layers. With these shifts, the visual landscape of the sky transforms over generations, reflecting the gradual evolution of our planet's climate. The changes in cloud altitude are not abrupt. They unfold slowly, weaving a tapestry of atmospheric behavior that tells a story of its own. Each cloud, floating high above, represents a moment in this journey, a snapshot of the many ways that our environment adapts and evolves. These fluctuations in cloud formation height are part of the broader narrative of the atmosphere's complex interplay, moving with a rhythm that is both calming and timeless. As temperatures change, air currents shift, and moisture swirls, the sky continues to embrace its own transformations, revealing the wonder of its continuous existence. Within the soft, billowing forms of a cloud, a quiet interplay occurs, driven by slight variations in temperature and humidity. These differences may seem small, yet they create internal pressure gradients that are essential to the cloud's existence. In this gentle realm of shifting air, movements arise from these delicate balances, guiding the formation and transformation of the cloud itself. Different sections of a cloud can possess unique conditions. Some areas may be cooler and more humid, while others might hold warmer, drier air. This variation lays the groundwork for internal forces that regulate how air circulates through the cloud. Air moves from areas of higher pressure to those of lower pressure, resulting in a subtle dance of air currents within the cloud's structure. This circulation plays a key role in defining the cloud's shape, density, and overall appearance. As these internal movements unfold, they contribute to the cloud's evolution over time. Patchy areas may thicken and swell, while others gradually dissipate. The intricate network of air flows continuously influences how droplets form, cluster together, and sometimes fall apart. This gentle and ever-shifting behavior contributes to the cloud's unique character on any given day. Together, these pressures and movements create a dynamic environment, alive with change. The delicate balance of temperature and humidity ensures that the cloud is not just a static collection of water droplets, but a vibrant, breathing entity that reflects the atmosphere around it. The serene motion of air within the cloud reminds us of the quiet yet profound complexity present in the natural world, unfolding softly with every moment. Within a cloud, a fascinating variety of water droplets exists, each differing in size. Some are larger and round, while others are significantly smaller and more delicate. This mixture of droplet sizes is a constant aspect of the cloud's makeup, influencing how it behaves in the atmosphere. Larger droplets tend to form through a process called coalescence, where they merge with nearby smaller droplets. This gentle blending allows them to grow, becoming heavier as they accumulate more water. The smaller droplets, meanwhile, can remain suspended for longer periods. They float and dance, capturing light in ways that contribute to the cloud's visual texture. While this size variation may seem simple, it plays an important role in cloud dynamics. The differing sizes lead to changes in how light refracts and scatters, affecting the cloud's color and brightness. Some areas of the cloud may appear more luminous due to clusters of tiny droplets, while others might seem darker as larger droplets gather. Over time, the presence of both large and small droplets works together to maintain a delicate balance within the cloud. Each droplet interacts softly with its neighbors, creating a harmonious environment where complex processes unfold without haste. The constant ebb and flow of the tiny water particles keeps the cloud in a state of gentle motion, evolving slowly as the sizes shift and change. This persistent mixture within the cloud allows it to adapt and respond to its surroundings, contributing to its ever-changing form. The peaceful coexistence of various droplet sizes reveals a tranquil complexity in nature, a quiet reminder of the intricate systems at play above us. In this way, the cloud continues to flourish, encapsulated in a world of its own. Lenticular clouds form in quiet grace, often near mountainous terrain, where they can maintain their distinct shape and position for extended periods. These clouds arise when moist air flows gently over the crest of a mountain range, encountering a stabilizing phenomenon. As the air rises and cools, the water vapor condenses into droplets, creating a smooth, lens-like formation. This unique shape, reminiscent of a stationary saucer, is the result of the air's consistent movement along both sides of the mountain. The surrounding atmosphere plays a vital role in allowing lenticular clouds to persist for hours. Stable weather conditions contribute to the cloud's ability to hold its form. The continuous flow of air from one side of the mountain to the other creates a cycle, effectively supporting the cloud as it gently sways in position. The air remains calm, facilitating this serene dance between the mountain and the cloud. Within this interaction, the cloud does not simply disperse. Instead, it is gently cradled by the atmospheric currents. The consistent airflow not only maintains the cloud's shape, but allows for a delicate balance where droplets remain suspended. This quiet stability allows one to observe the cloud as it hovers, seemingly undisturbed by the environment around it. As the light shifts through the day, the cloud may take on varied hues, subtly reflecting the sun or becoming softer in the dusk. Each moment offers a new view, yet this tranquil formation remains a constant presence, embodying the harmony of nature's cycles. The way lenticular clouds linger above the mountains serves as a reminder of the quiet forces operating in the atmosphere, maintaining their gentle existence amid the expansive sky. The Atlantic multidecadal oscillation, often simply referred to as the AMO, embodies a natural rhythm in the North Atlantic Ocean, characterized by a cycle of sea surface temperature variations. This cycle unfolds over lengthy periods, typically lasting between 20 to 40 years. During each phase, temperatures may fluctuate, leading to noticeable changes in oceanic and atmospheric behavior. As ocean temperatures rise or fall, the surrounding air is gently influenced by these conditions. Warm ocean waters can enhance the likelihood of energy being released into the atmosphere, creating an environment that may foster increased hurricane activity. Conversely, cooler waters reshape this dynamic, leading to calmer seas. The interplay of these temperatures has a ripple effect, interacting with various atmospheric patterns that extend far beyond the ocean's immediate reach. Rainfall patterns also shift subtly with each phase of the AMO. Areas experiencing enhanced warmth might see consistent rainfall, nurturing verdant landscapes, whereas cooler periods may lead to drier conditions, altering local ecosystems. Cloud cover responds to these evolving ocean temperatures as well, changing both in density and type. Different clouds emerge in response to the varying heat, shaping their structures and the way they drift across the sky. Over time, the AMO creates an interconnected tapestry, woven by the nuances of sea and sky. The gentle ebb and flow of this cycle serve as a reminder of nature's complexity, as the Atlantic Ocean continues to resonate with the rhythms of the Earth. Each phase gently guides the atmospheric conditions, fostering a dynamic, ever-changing environment. This peaceful dance unfolds quietly, echoing through the years, maintaining a steady presence in the larger climatic narrative. Clouds emerge from the delicate dance of water vapor within the atmosphere. When air begins to rise, it encounters cooler temperatures at higher altitudes. This cooling acts as a gentle trigger, coaxing water vapor to transition into tiny droplets of liquid water. As the air cools, the capacity to hold moisture reduces, leading to condensation. Through this serene process, clouds start to form, gradually taking shape as more and more droplets gather. The rise of air often occurs in places where atmospheric instability is present. Each puff of warm air lifts upward into the cooler regions of the atmosphere, carrying with it the moisture that has evaporated from oceans, lakes, and rivers below. As this air ascends, it expands and cools, creating a calm transformation of invisible vapor into visible water droplets. These droplets cluster together, merging and coalescing, eventually becoming what we see as clouds. The appearance of clouds can vary widely, from fleeting wisps to thick, layered formations. Each type tells a story of the air's journey and the conditions it has encountered. Stratus clouds may blanket the sky with a soft, uniform layer, while cumulus clouds pop up like fluffy pillows, each one a symbol of the air's instability and its capacity to rise. Over time, these clouds drift slowly, driven by gentle winds, painting the sky with their ever-changing forms. And in this continuous cycle, clouds serve as a reminder of the intricate processes occurring in our atmosphere. The simple act of rising air and its cooling creates a beautiful spectacle above, where droplets form and gather, softly shifting shapes in response to the surrounding air's behavior. Observing this quiet choreography can evoke a sense of peace as nature unfolds in its own serene rhythm, endlessly renewing itself in the vast sky overhead. The southern annular mode expresses itself through the westerly wind belt that encircles Antarctica, a wind system that gently shapes the atmosphere. This belt of winds can shift north or south, influenced by a variety of atmospheric conditions. While its movements may create shorter-term fluctuations in weather, the longer-term shifts hold a significant presence, altering patterns that influence the southern hemisphere. As the westerly winds move, they can bring changes in pressure systems, which in turn affect weather patterns far beyond Antarctica. The gentle push of these winds can alter cloud formation and precipitation levels over different regions. For instance, when the wind belt shifts southward, it may lead to wetter conditions in some areas, while bringing drier skies to others. The myriad of changes that occur during these shifts shapes the atmosphere, weaving a complex tapestry of weather systems that reflects the delicate balance of nature. Over the years, patterns emerge, highlighting the tendency of the SAM to exhibit variability. The long-term behavior can almost feel like a rhythm, a pulse within the climate system, affecting ocean currents and atmospheric circulation. This interaction plays a subtle role in the ecological balance, creating an ongoing cycle that influences life in the southern hemisphere. The vastness of this interaction, often unseen, acts around us, shaping the air we breathe and the weather we experience. As these westerly winds move and shift, they are a reminder of the dynamic nature of our planet. Their patterns contribute to a complex and interconnected system, continuously changing, yet inherently linked to the larger atmospheric dance of the Earth. Each shift of the SAM carries with it the potential for new weather, forming clouds and altering the skies, shifting as they have for countless years, quietly weaving together the fabric of our environment. Deep ocean circulation patterns, such as the Thermo-Holland circulation, work through the complex interplay of various water masses. This circulation, often referred to as the Atlantic Meridional Overturning Circulation, is a slow but powerful movement spanning centuries and even millennia. It resembles a vast, unseen conveyor belt, transporting large quantities of seawater across the globe, deeply influencing the Earth's climate. The dynamics of this flow are driven largely by differences in water density, which is influenced by both temperature and salinity. Warmer water, typically found near the ocean's surface, rises and moves towards the poles, where it gradually cools. As the water becomes denser, it sinks, creating a cycle that brings cold, nutrient-rich water from the depths back to the surface in other regions. This process contributes significantly to the overall distribution of heat throughout the oceans, making it a critical driver of the climate system. When changes occur within these currents, they can ripple throughout the globe. Such alterations modify heat distribution, affecting not only ocean temperatures, but also atmospheric conditions. As warm and cold waters interact, they influence cloud formation and weather patterns, leading to shifts in precipitation and temperature over various regions. This delicate balance plays a crucial role in the long-term climate system, quietly connecting disparate parts of the Earth. The vast reach of these ocean currents serves to underscore their importance in maintaining the intricate equilibrium of our planet's climate. Each small change in temperature, salinity, or flow speed can initiate a cascade of effects that reshape the way we understand our environment. As water moves and swirls through the unseen currents below, the Earth feels their influence, a gentle reminder of the complexity that lies beneath the surface, quietly shaping the world we know. Cumulonimbus clouds, often observed towering high in the sky, are a remarkable feature of our atmosphere. These clouds can take on an impressive stature, sometimes reaching heights that extend into the stratosphere. They thrive in conditions where there is strong atmospheric instability, which means that warm, moist air can rise rapidly. This upward movement of air contributes to their dynamic appearance and resiliency. In the presence of abundant moisture, these clouds can maintain their active state for extended periods. Though individual cells within a cumulonimbus cloud may dissipate and reform, the cloud itself can persist, constantly evolving as it interacts with the surrounding air. The exchanges between warmer, rising air and cooler, descending air help sustain the cloud's life cycle. They can grow and develop in a consistent manner, even as parts of them fade away. The formation of cumulonimbus clouds is intricately linked to the energy present in the atmosphere. This energy, combined with moisture, fuels the processes that create rain, hail, and sometimes even lightning. The cycles of evaporation and condensation they embody contribute to the continuous movement of water through the atmosphere. As these clouds drift and change, they transform the environment in subtle but significant ways. Over time, their presence can alter local weather conditions, affecting temperature and precipitation patterns. Each formation of cumulonimbus clouds is a harmonious part of a larger system, a gentle indication of the constant dance occurring in our skies. Observing their majestic, ever-changing forms invites a sense of calmness, reflecting the beauty of nature's intricacies. The atmosphere continues its rhythmic flow, and the clouds remain a quiet testament to the forces at play, ready to unfold their effects upon the world below. The 470-day atmospheric wave, often connected to the Madden-Julian oscillation, is a fascinating phenomenon within the atmosphere. This wave exhibits a dominant period of around 30 to 60 days. Although this duration might not be considered long-term in the context of decades, its effects unfold in a rhythmic manner. The oscillation carries energy that influences weather patterns around the globe, creating a gentle ebb and flow in atmospheric conditions. As the wave propagates eastward, it generates distinct phases that either enhance or suppress convection processes. During the active phases, areas of rising air can lead to increased cloud formation and rainfall. In contrast, the inactive phases allow for quieter conditions with less convection. This cycle influences the distribution of cloud bands as they shift across regions, marking out pathways of moisture and precipitation. The patterns produced by these oscillations can have far-reaching impacts, affecting climate systems in diverse areas. The dance of the atmosphere continues as the phases transition, layering complexity upon simplicity. Air masses interact with one another, responding to the subtle nudges imparted by these waves. Even as the world seems still, the atmospheric dynamics are at play, guiding the formation and movement of clouds in their silent, persistent manner. This continuous cycle fosters a balance in how energy and moisture circulate. The consistency of these patterns underlines a delicate interconnectedness within the atmosphere. Each oscillation stands as a gentle reminder of the natural order, quietly shaping the weather with a soothing predictability. With each phase shift, the sky responds, ever evolving, yet remaining a constant source of wonder. The formation and stability of clouds hinge on the delicate balance of rising air currents. When these updrafts are strong, they carry moisture-laden air upward, allowing water vapor to condense into tiny droplets, gathering together to form a cloud. This process is a continuous exchange where warm air ascends, creating a space for cooler air to descend. In this dance, clouds thrive, growing and evolving in response to the moving atmosphere around them. However, a threshold of stability exists that can bring this cycle to a gentle halt. When rising air currents begin to weaken or cease entirely, the environment shifts. Without the pushing force of continuous updrafts, the ability of air to hold water vapor diminishes. The tiny droplets that once filled the sky lose their support, making it difficult for them to remain suspended. In moments like this, clouds will inevitably begin to dissipate, gently fading as the water vapor escapes back into the atmosphere, returning to its invisible state. This transition occurs quietly, often unnoticed, as the sky transforms in soft, subtle ways. As clouds dissipate, they leave behind a calmness, creating a sense of stillness in the air. The gentle ebb of this process signifies a temporary pause in the cycle of cloud formation. Each phase of stability and instability is an essential part of the atmospheric rhythm, fostering an intricate interplay within the air. This dynamic stability draws our attention subtly, reminding us of the ever-changing yet tranquil nature of the skies above. The atmosphere continues its quiet functioning, each moment leading into the next, as the world unfolds softly around us. Within a cloud, the process of condensation unfolds quietly. As water vapor condenses into tiny droplets, it releases latent heat. This is a gentle warmth that slowly seeps into the surrounding air. It has a subtle yet significant effect, slightly increasing the temperature around the droplets. This warmth creates small buoyancy forces, which help lift the air surrounding the cloud. With each tiny droplet forming, the cloud begins to grow. The upwards movement of the warm air lifts even more moisture-laden air from below, allowing the cloud to expand and flourish. In this way, the released heat becomes a continuous cycle of growth. As the cloud gains energy from warm air rising, it stands resilient against the cooler air above. This internal heating mechanism plays a crucial role in the cloud's persistence. Without this gentle release of heat, clouds might dissipate much more quickly when updrafts weaken. Instead, as droplets form and warm the surrounding air, the cloud finds the means to sustain itself for a longer duration. It remains a part of the dynamic atmosphere, adapting to changes and gently interacting with its environment. The sense of gentle warmth lingers within clouds, subtly nurturing their stability. It is a soft reminder of the continuous processes that shape the skies, inviting the imagination to drift along with the formations above. As clouds rise and evolve, their presence adds a calming texture to the ever-changing sky, enveloping everything in a quiet embrace. The rhythm of condensation and thermal dynamics continues, ever present, like a soft lullaby in the expansive atmosphere. In the polar regions, there are times when the air becomes extremely cold. This frigid temperature creates a stable atmosphere in the winter stratosphere, a layer of air high above the surface. Under these special conditions, polar stratospheric clouds begin to form. They are delicate structures composed mainly of tiny ice crystals. The chilling air provides the perfect environment for these clouds to exist, allowing them to thrive for many months. The stability of the stratosphere is essential. It keeps the air calm and still, providing a gentle backdrop for the formation of these clouds. The low temperatures mean that the moisture in the air can freeze into tiny crystals. The crystals cluster together, gradually building up the luminous clouds that glisten in the cold light of the polar skies. Unlike clouds that are formed in warmer conditions, these polar stratospheric clouds persist through the long, dark winter. As they float high above the ground, they remain anchored in the cold air, untouched by the warmth that resides below. Days blend into nights, and still they linger, shimmering softly against the vast, dark expanse. This remarkable endurance showcases the unique interplay of elements that exist in the polar stratosphere. These clouds serve as a faint reminder of the deep and intricate processes occurring in the atmosphere, quietly reflecting the environment from which they arise. In their stillness, they bring a sense of tranquility, inviting thoughts to wander gently, like the clouds themselves, amid the icy air above. The ceaseless nature of their existence continues, flowing in harmony with the serene backdrop of wintry polar nights. In the gentle embrace of a cloud, tiny water droplets drift and float in a delicate dance. Each droplet, small yet full of potential, exists within an environment rich in moisture and movement. They are ever in motion, colliding softly with one another, forming a quiet symphony of interactions. When two droplets meet, there is a simple yet important moment when they join together, a process known as coalescence. This merging does not occur without effort. Each time droplets collide, the surface tension between them comes into play. This tension is a subtle force, almost like an invisible membrane that keeps them separate. To unite, the droplets must overcome this tension, and that requires energy. This energy is a fundamental aspect of their shared existence, absorbed during each gentle interaction. The more often they collide, the more droplets gather, gradually combining into larger entities. Over time, these interactions lead to growth. As droplets continue to collide and coalesce, they share energy, leading to the formation of droplets that are increasingly substantial. The gentle process occurs continuously, allowing the droplets to evolve slowly, enhancing their size in the comforting cloudiness that surrounds them. These energy-absorbing moments persist over longer periods, providing a rhythm to the cloud's life. The constant interactions mold the structure of the cloud itself, influencing its shape and density. In this serene world high above, a hidden harmony unfolds, where droplets continuously grow and shift, reflecting the calm yet dynamic nature of their surroundings. Each moment contributes to the overall presence of the cloud, softly reminding us of the quiet beauty inherent in nature's delicate processes. Within the gentle expanse of a cloud, a delicate balance exists, where temperature varies from one small area to another. Though a cloud may seem like a uniform white blanket, it is in fact a collection of unique pockets, each holding slightly different temperatures. These variations are subtle, often unnoticed, yet they play a vital role in the cloud's behavior and characteristics. Each pocket of air within the cloud can hold its own specific temperature, influenced by factors such as altitude, the movement of air currents, and the overall humidity of the environment. These differences help create a gentle tapestry of thermal layers, with some areas perhaps a bit cooler and others slightly warmer. This subtle interplay remains relatively stable over time, allowing the cloud to maintain a certain structure, even as it shifts and flows through the sky. As air moves and circulates within the cloud, these small temperature differences encourage a slow dance of movement and change. Warmer air tends to rise, while cooler air descends, creating a harmonious flow that feeds into the cloud's formation. Despite the mobility of the air, the temperatures remain consistent enough to nurture the water droplets suspended within. This intricate balance helps sustain the cloud, contributing to its softness and billowy appearance. Each temperature pocket adds a layer of complexity, reinforcing the idea that what appears as a singular entity is indeed a rich, textured environment. Within this tranquil realm, pockets of varying temperature exist harmoniously, reflecting the quiet and peaceful processes that define its existence, continuing to drift softly across the vastness above. Over long periods, the delicate dance of clouds and climate unfolds across the planet. The types of clouds that grace the sky in one region can shift and migrate as climate zones gradually change. This transformation happens with a gentle, almost imperceptible rhythm. While cloud types may seem like a constant feature of the atmosphere, they are, in truth, linked intricately to the broader environmental context. As temperatures fluctuate and weather patterns evolve, the areas where specific cloud formations thrive may slowly drift. For example, the warm, moist air that nurtures cumulus clouds might move, creating new conditions for these clouds to flourish in different locations than before. Stratus clouds, which thrive in cooler, more moist regions, may follow suit, gradually finding new homes in response to shifting temperatures. This slow migration reflects the ever-changing relationship between the atmosphere and the earth beneath it. Cloud patterns are not static. Instead, they flow gracefully with the currents of air and the cycles of temperature. Over time, the landscape of clouds can feel as if it has transformed, with familiar formations appearing in new places and other types receding as climates evolve. The gentle movement of these clouds serves as a reminder of the intricate balance of the Earth's systems, where every whisper of change in temperature or moisture can lead to a soft reconfiguration of the skies. As this slow migration continues, it remains an essential part of the broader story of our atmosphere, a tranquil aspect of a constant cycle that persists across time. Each cloud type may wander, draping its unique form over new terrains, preserving the gentle artistry of our skies, inviting a peaceful sense of continuity as they drift calmly onward. Orographic clouds gracefully emerge in response to the gentle rise of moist air, meeting the solid presence of mountains. As the wind carries moisture-laden breezes, they encounter the elevation of the land, which gently nudges the air upwards. This upward movement cools the air, leading to condensation. Tiny water droplets begin to cluster and form clouds, creating a soft, fluid layer that drapes around the peaks and valleys. When conditions allow for a steady supply of moisture, these clouds can linger, settling into a steady presence over the mountain range. Their forms can evolve, revealing various textures and densities as the environmental conditions shift and flow. Some days, this blanket of cloud may appear wispy and ethereal, while on others, it could take on a thicker, more robust appearance, heavy with droplets waiting to release their moisture. The sustained existence of orographic clouds hinges on the delicate balance of ongoing wind patterns and humidity levels. A consistent flow of air keeps them present, while any shifts in these conditions may cause them to dissipate or reform, much like a gentle breath in the atmosphere. The clouds seem to embody a quiet persistence, gently shaping the landscape beneath them and creating a unique ecosystem around the mountains. As they drift, these clouds witness the gradual changes in their surroundings. They contribute to the soft, serene cycles of weather that define the landscapes they adorn. Their tranquil presence offers a soothing reminder of the endless dance of air and moisture, poising themselves delicately above the earth, enhancing the natural harmony of the mountain scene. Each new formation blends seamlessly into the existing tapestry of the atmosphere, ready to embrace the gentle shifts of time and elements above. Softness envelops the mind as the world begins to quiet. Each breath flows in and out, gentle and steady, like the rising and falling of the earth itself. The quiet rustling of leaves can be imagined, harmonizing with the whisper of the wind. All around is a cocoon of stillness. Feel the warmth of rest seeping in, gently cradling thoughts in a tender embrace. The mind drifts, settled in the comfort of familiar patterns. In the hush of the evening, the soft glow of distant stars offers a sense of peace. Each twinkle invites calmness, a subtle reminder of the vastness above. The clouds linger softly like a gentle caress, resting above the mountains, their forms blending into the night sky. Time moves slowly, as if wrapped in a layer of comfort, inviting every moment to be savored. Reflect on the quiet power of nature, how it embodies serenity. Consider the way the clouds shift in the stillness, endlessly drifting, yet ever so slightly grounded in place, soft reminders of tranquility. Each breath deepens into relaxation. Every exhale releases the day, allowing thoughts to settle softly, like leaves upon gentle waters. The heartbeat of nature whispers lullabies, reassuring and rhythmic. Allow all tension to melt away, flowing with the calmness of the tranquil world around. Embrace the stillness. Let it wash over you like a gentle tide. Feel the weight of your body supported, cradled in the soothing embrace of the night. In this moment, understand that everything is serene, the air is calm, and there is no rush. The quiet unfolds naturally, taking you deeper into rest. Thoughts drift softly, tethered to the comfort of the familiar. With each passing moment, awareness coaxes you into deeper layers of peace, inviting sleep to envelop like a comforting blanket, secure and warm. With every gentle breath, let go a little more. Allow the night to embrace you within its tender hold, guiding you into a realm where the world feels light and dreams beckon softly. In this sacred space, tranquility reigns and all is well. Good night from Sleepy Science Facts.